In the vast expanse of the cosmos, where stars twinkle like distant dreams and galaxies dance across the grand tapestry of space-time, there exists a realm shrouded in profound mystery and unimaginable power, the enigmatic phenomenon known as black holes. These cosmic giants are born from the violent and cataclysmic deaths of massive stars. Stars so immense that their final moments result in an extraordinary transformation. When these colossal stars exhaust their nuclear fuel, they undergo a gravitational collapse, compressing their mass into an incredibly dense point known as a singularity. Surrounding this singularity is the event horizon, an invisible boundary marking the point of no return, beyond which nothing, not even light, can escape the overwhelming grip of gravity. Black holes are unlike any other objects in the universe. Their immense gravitational pull warps the very fabric of space and time, creating distortions so extreme that our conventional understanding of physics begins to break down. This warping effect means that time itself slows down near a black hole's event horizon, a concept predicted by Einstein's theory of general relativity and confirmed through various astronomical observations. For decades, black holes have fascinated scientists and the public alike, inspiring countless theories, research, and even popular culture phenomena. Yet, despite their fame, black holes remain some of the most elusive and least understood objects in the cosmos. Because they emit no light and absorb everything around them, detecting black holes requires indirect methods. Observing the behavior of nearby stars, gas, and light that bend and swirl under their influence. Among the vast family of black holes, there exists a remarkable diversity. Some are stellar mass black holes, remnants of individual stars several times more massive than our Sun. These black holes, though smaller in size, pack a punch with gravitational forces strong enough to trap anything crossing their event horizon. At the other end of the scale lie supermassive black holes, colossal entities millions to billions of times the mass of our Sun. These giants anchor the centers of most galaxies, including our own Milky Way, playing a crucial role in galaxy formation and evolution. Their gravitational dominance shapes the motion of stars, influences cosmic structures, and may even regulate the growth of galaxies over billions of years. One of the most groundbreaking achievements in recent years was the first ever direct imaging of a black hole's event horizon by the Event Horizon Telescope collaboration. This historic image revealed the glowing ring of hot gas swirling round the dark silhouette of a supermassive black hole in the galaxy M87, providing visual proof of black holes' existence. Beyond their awe-inspiring physical properties, black holes also open doors to the deepest questions about the universe itself. What happens inside the singularity? How does information behave beyond the event horizon? Could black holes be gateways to other universes or dimensions? These are questions at the frontier of modern physics, inspiring new theories like quantum gravity and string theory. Moreover, black holes play a vital role in cosmic evolution. Their mergers generate powerful gravitational waves. Ripples in space-time first detected in 2015 that provide a new way to observe the universe. These waves carry invaluable information about black hole properties, their environments, and even the fundamental nature of gravity. As humanity's technology advances, telescopes and observatories continue to probe deeper into the cosmos, unraveling the mysteries of black holes and their cosmic dances. Missions like the European Space Agency's Gaia telescope map billions of stars, helping identify hidden black holes by observing their gravitational effects on companion stars. In this journey to understand black holes, we not only explore the extremes of nature, but also our place within the vast cosmos. These mysterious objects remind us of the limits of our knowledge and the incredible potential of human curiosity and ingenuity. Join us as we venture into this cosmic enigma, where science meets wonder and every discovery brings us closer to understanding the breathtaking universe we call home. Black holes have captivated human imagination for decades, inspiring endless inquiries, philosophical debates, and countless narratives woven into popular culture. Their chilling beauty and awe-inspiring might evoke a profound sense of wonder. But these cosmic giants are more than just mysterious objects. They carry the potential to fundamentally reshape our understanding of the universe in ways that both astound and humble us. Imagine for a moment the perils that lurk within the vicinity of these gravitational titans. Space, with all its vastness, can already be a terrifying frontier. Its dangers magnified exponentially when one ventures near a black hole. These celestial giants wield gravitational forces so intense that they warp space and time itself, creating a domain where the known laws of physics begin to unravel. Approaching a black hole is like stepping into the unknown. Beyond the event horizon lies a realm where conventional understanding collapses, and the fabric of reality is twisted into something almost incomprehensible. Here, time slows, space contorts, and matter is crushed into an infinitely dense point called the singularity. But the enigma of black holes extends beyond their destructive power. They challenge our very conception of reality, forcing scientists to rethink fundamental concepts of space, time, and information. Could the mysteries locked within black holes hold clues to unifying quantum mechanics with gravity? Might they offer insights into the origins of the universe, or the true nature of reality itself? These questions fuel ongoing scientific research and spark intense philosophical debates. The paradoxes surrounding black holes, such as the fate of information that falls into them, push the boundaries of our knowledge and invite us to contemplate the limits of human understanding. At the same time, black holes serve as a humbling reminder of our place in the cosmos. They are cosmic gatekeepers to the unknown, inviting us to explore, question, and dream beyond the horizons of what we currently know. As we continue to probe these mysterious phenomena with ever-advancing technology and human curiosity, black holes remain not just terrifying cosmic phenomena, but also profound symbols of the universe's awe-inspiring complexity and grandeur. Even the very concept of space exploration is tinged with trepidation, a mixture of awe, curiosity, and deep uncertainty. It is the vast, uncharted unknown that both terrifies and beckons us, urging humanity to traverse the cosmic void and uncover the secrets hidden among the stars. Among all the celestial wonders scattered across the universe, black holes hold a uniquely powerful allure. They captivate the imagination like no other phenomenon, inspiring feelings of both intrigue and terror in equal measure. At the heart of every black hole lies a singularity, a point where mass is crushed into an unimaginably small and dense space, an infinitesimal point where the laws of physics as we know them break down. This singularity creates a gravitational pull so overwhelmingly potent that even light, the fastest traveler in the universe, cannot escape its grasp. The boundary surrounding this point, known as the event horizon, marks a cosmic threshold, Once anything crosses this invisible boundary, escape becomes impossible. It is forever drawn into the black hole's cosmic abyss, trapped by forces so immense they defy human intuition. This captivating and terrifying reality challenges our understanding of nature, pushing the limits of science and philosophy alike. The event horizon is a point of no return, a veil beyond which time and space themselves are warped, leaving behind a mystery that continues to fascinate and mystify researchers. Yet, it is precisely this mysterious nature that fuels our desire to explore, to learn, and to push beyond the limits of what we know. Black holes represent the ultimate frontier, an enigmatic reminder of the universe's boundless power and the infinite questions that lie beyond the stars. While black holes may often seem like creatures born from the imagination of science fiction, the quest to truly understand their nature has become one of the most profound and compelling pursuits in modern scientific exploration. Across the globe, astrophysicists have devoted their lives to unraveling the mysteries of these enigmatic cosmic phenomena. Using an arsenal of cutting-edge technology, from space telescopes to gravitational wave detectors, they probe deeper into the darkness than ever before. Yet, with each discovery, the mysteries surrounding black holes only seem to grow more complex, urging us to reconsider the very fabric of reality itself. These celestial enigmas challenge our fundamental understanding of space, time, and the laws that govern the universe. Amid this relentless pursuit of knowledge, a revelation of cosmic proportions has recently emerged, one that comes from none other than the celebrated astrophysicist Neil deGrasse Tyson. Known for his ability to translate the complexities of the universe into accessible insights, Tyson has shared ideas that challenge our preconceived notions and dramatically expand the horizon of our cosmic understanding. His perspective invites us to not only appreciate black holes as astronomical objects, but also as gateways to deeper questions about the universe's origin, structure, and ultimate fate. As we stand at this new frontier of knowledge, Tyson's revelations inspire both awe and humility, reminding us that in the vast cosmic dance, our journey of discovery has only just begun. Recent revelations in astrophysics have painted a breathtaking portrait of our universe, shedding light on the staggering contrasts that exist even among the most enigmatic phenomena. Black holes. While the black hole, situated in our cosmic neighborhood, the one closest to Earth, commands awe and respect for its sheer power and mystery, it is, in the grand cosmic scale, a relatively modest player. Far beyond our local sphere lies the gargantuan singularity residing at the very heart of the Andromeda Galaxy, our majestic and nearest galactic neighbor. This colossal black hole, millions or perhaps billions of times more massive than our Sun, exerts a gravitational influence so immense that it governs the motion of entire star systems and shapes the evolution of the galaxy itself. This profound revelation sparks a renewed sense of cosmic competition and wonder, a reminder of the vastness of the universe and the scale of mysteries it holds. As inhabitants of Earth, mere specks in this boundless expanse, we find ourselves captivated by the allure of the cosmos. Our insatiable curiosity drives us onward, compelling us to probe ever deeper into the fabric of space and time, to uncover the secrets hidden within the celestial depths. This sense of cosmic rivalry between our Milky Way's own central black hole and Andromeda's gargantuan core stirs our imagination and ignites our scientific ambitions. It symbolizes the never-ending quest for knowledge that defines human nature, a quest to understand not only our own galactic home, but also our place within the grand cosmic tapestry. As the story unfolds, we see a symphony of cosmic phenomena playing out on an unimaginable scale. Galaxies swirl in vast cosmic ballets, stars ignite and fade, and black holes command their stellar companions with a gravitational grip that defies comprehension. The gravitational waves rippling through space, the bending of light as it skirts these titanic masses, and the dark mysteries lurking behind event horizons, all weave together to compose this cosmic opera. For scientists and dreamers alike, these discoveries serve as both a challenge and an inspiration, challenging our existing models of physics and cosmology and inspiring the next generation of explorers to push the boundaries of what humanity can achieve. Each breakthrough brings us closer to understanding the fundamental laws that govern the universe, unlocking secrets that could one day redefine our comprehension of reality itself. In this vast and dynamic universe, our journey is far from over. With advanced telescopes, space probes, and the relentless ingenuity of human curiosity, we continue to peer deeper into the darkness, hoping to illuminate the unknown. The titanic black hole at the core of Andromeda stands as a monumental beacon in this journey, a reminder of the cosmic wonders that await us as we reach toward the stars and beyond. As we stand on the cusp of an extraordinary voyage, humanity is poised to embark on a journey unlike any before, an odyssey through interstellar space that promises to unveil the unfathomable interior of a black hole. This exploration is not just a scientific endeavor. It is a bold leap into the unknown, one that has the potential to shatter the very foundations of human comprehension and transform our understanding of the universe itself. But what truly lies within the heart of a black hole? Despite decades of study and countless theories, the answer remains tantalizingly out of reach. Black holes are cosmic anomalies, born from the violent and dramatic demise of massive stars. When these stellar giants exhaust their nuclear fuel, they undergo a cataclysmic explosion known as a supernova, an event so powerful it outshines entire galaxies for brief moments. What remains after this cosmic explosion is a core so dense and compact that it collapses under its own gravity, compressing matter and energy into a point known as the singularity. The singularity is a place where the known laws of physics break down, a point of infinite density where space and time themselves are warped beyond recognition. Surrounding this enigmatic core is the event horizon, a boundary beyond which nothing, not even light, can escape the black hole's gravitational grasp. Crossing this threshold means venturing into a realm where reality bends and our conventional understanding of time and space ceases to apply. As we prepare to delve deeper into these cosmic mysteries, armed with the latest advancements in technology and theoretical physics, we confront not only the marvels of the universe, but also the limits of human knowledge. Each new discovery pushes us further into the cosmic abyss, inviting us to reconsider what we know about existence and challenging us to imagine the unimaginable. This journey through the heart of a black hole is more than a scientific pursuit. It is a testament to humanity's relentless curiosity and unyielding desire to explore the cosmos. It symbolizes our drive to reach beyond the stars, to seek answers in the darkest corners of space, and to illuminate the mysteries that lie hidden within the fabric of the universe. The extreme curvature at the heart of a black hole defies the very boundaries of our current understanding of physics. At this cosmic crossroads, the familiar laws of nature unravel and the theoretical frameworks that have guided centuries of scientific thought begin to crumble. What remains are paradoxes, puzzles that challenge our deepest assumptions and demand innovative resolutions. Singularities, those enigmatic points of infinite curvature and density, are not merely cosmic curiosities. They resonate with the origins of our universe itself. The singularity at the heart of a black hole shares a profound kinship with the Big Bang singularity, the mysterious starting point of our cosmos. Both represent extreme conditions where space, time, and matter are compressed beyond conventional comprehension. As we strive to unravel these enigmas, a promising contender in the realm of theoretical physics rises: the theory of loop quantum gravity. This innovative framework seeks to unify the principles of quantum mechanics, which governs the incredibly small, and general relativity, which describes the vast cosmos. Loop quantum gravity suggests that space-time is not a smooth, continuous fabric, but instead is granular, composed of tiny, discrete, and indivisible elements woven together like the threads of a cosmic tapestry. This radical idea offers a new lens through which to view singularities, hinting that the infinite densities we once imagined might be replaced by a quantum structure where the laws of physics regain coherence. Through this theory, we edge closer to resolving the paradoxes of black holes, opening pathways to a deeper, more unified understanding of the universe's most profound mysteries. Known as loops or spin networks, these fundamental building blocks within the framework of loop quantum gravity transform singularities from insurmountable paradoxes into fascinating points of scientific exploration. They guide us toward deeper recesses of cosmic understanding, offering new pathways to decode the mysteries hidden at the heart of black holes. Peering into the very core of these cosmic enigmas requires instruments of remarkable precision and ingenuity. Enter the Very Large Telescope, nestled high within the Paranal Observatory in Chile. This technological marvel consists of a quartet of individual telescopes, each boasting an 8.2-meter primary mirror, working in unison and paired with advanced instruments such as the multi-unit spectroscopic explorer. These telescopes provide astronomers with an unprecedented window into the dark and mysterious regions surrounding black holes. Yet, the pinnacle of humanity's cosmic observatories is the Event Horizon Telescope, a groundbreaking global network of radio observatories scattered across the Earth. By synchronizing these observatories to function as a single Earth-sized virtual telescope, scientists have achieved unprecedented resolution. This has allowed them to capture the first ever image of a black hole's event horizon, transforming theoretical physics into tangible, awe-inspiring reality. Together, these technological triumphs propel us closer than ever to unraveling the secrets of black holes, expanding our cosmic horizons and deepening our understanding of the universe's most enigmatic phenomena. Synchronously gazing upon the cosmos, the Event Horizon Telescope, an extraordinary collaborative endeavor uniting observatories across the globe, achieved a historic milestone by capturing the first ever direct image of a black hole's event horizon. This remarkable feat marked a turning point in astrophysics, thrusting the once theoretical and elusive phenomena of black holes into the tangible realm of observable science. By revealing the shadow cast by the immense gravitational pull of the black hole at the center of galaxy M87, the Event Horizon Telescope validated decades of predictions derived from Einstein's general theory of relativity and set a new benchmark for precision and innovation in astronomical observation. This accomplishment not only deepened our understanding of how black holes behave, but also paved the way for an array of future investigations into the extreme environments surrounding these cosmic giants. The image served as a vivid testament to human ingenuity and the power of international cooperation, demonstrating that by working together we can pierce the veil of the universe's most profound mysteries. Yet, the story of black holes is far from complete. Beyond the known horizons of gravity and matter lies a realm that tests the very limits of physics. The mysterious and captivating concept of wormholes. These hypothetical passages, theorized within the framework of Einstein's field equations and later expanded by numerous physicists, propose the existence of tunnels through the fabric of space-time. If real and traversable, wormholes could act as shortcuts across unimaginable cosmic distances, potentially linking distant points in our universe, or even providing gateways to entirely separate universes or dimensions. The idea of wormholes stretches our imagination and challenges our current scientific paradigms. Unlike black holes, which are often perceived as cosmic traps from which nothing can escape, wormholes offer a vision of passage and connectivity, a bridge linking disparate regions of space-time that could revolutionize travel and communication on a universal scale. While still firmly in the realm of theoretical physics, wormholes inspire both scientific inquiry and science fiction alike, blurring the lines between what is known, what is possible, and what is yet to be discovered. If traversable wormholes exist, they could dramatically alter humanity's understanding of the cosmos. They might provide pathways to distant galaxies that would otherwise take millions of years to reach, or reveal hidden dimensions that transcend our three-dimensional perception of reality. Such prospects invite profound philosophical questions about the nature of existence, causality, and the interconnectedness of all things in the universe. However, the existence and stability of wormholes present formidable challenges. Theoretical models suggest that, to keep a wormhole open, exotic matter with negative energy density, something never observed directly, would be required. Moreover, the effects of quantum gravity, still a largely uncharted territory, play a critical role in determining whether such structures could persist long enough for passage or communication. Despite these obstacles, the pursuit of knowledge surrounding black holes and wormholes propels scientists to develop ever more advanced observational techniques and theoretical frameworks. Instruments like the Event Horizon Telescope, the Very Large Telescope, and the upcoming James Webb Space Telescope provide unprecedented views of black holes and their environments, offering clues about the behavior of matter and energy under extreme conditions. In addition, ongoing research into quantum gravity theories, such as string theory and loop quantum gravity, aims to unify the laws of the very large and the very small, potentially illuminating the fundamental nature of space-time itself and the true nature of singularities and wormholes. As humanity ventures further into this cosmic odyssey, the study of black holes serves as both a symbol and a beacon, a testament to our relentless curiosity and our capacity to confront the unknown. These cosmic enigmas challenge us to rethink the boundaries of science, to embrace complexity and uncertainty, and to keep pushing the frontiers of discovery. Ultimately, black holes and wormholes invite us to reflect on our place in the vast universe and inspire us to dream beyond the stars. They remind us that the cosmos is not a static backdrop, but a dynamic and mysterious landscape filled with wonders waiting to be unveiled by those who dare to explore. In the vast cosmic theater where black holes reside, the very fabric of space-time undergoes dramatic and profound transformations. These enigmatic giants do more than simply pull in matter and light. They fundamentally alter the essence of reality itself. As we weave the narrative of black holes, threads of curiosity and audacity intertwine, compelling us to confront some of the deepest and most perplexing questions about the universe. One of the most fascinating and mind-bending phenomena associated with black holes is the warping and bending of space-time. According to Einstein's theory of general relativity, massive objects like black holes cause space and time to curve around them. This curvature is not merely a geometric oddity, it has tangible and astonishing consequences on the flow of time, a phenomenon known as time dilation. Time dilation reveals that time is not the absolute, steady river we once imagined, but a malleable construct, intricately influenced by gravity. Near a black hole, where gravitational forces reach unimaginable intensity, time slows down dramatically relative to an observer farther away. Imagine two observers, one watching from a safe distance and another venturing close to the event horizon of a black hole. For the distant observer, time for the traveler near the black hole appears to tick slower and slower. Meanwhile, the traveler experiences time at their usual pace, but will notice the outside world speeding up dramatically. This discrepancy in the passage of time leads to extraordinary implications. If a person could safely orbit close to a black hole and then return to Earth, they might find that many years or even centuries have passed for those who remained behind. The slow march of time near the black hole could, in theory, provide a gateway to a form of cosmic time travel, one governed not by machines, but by the very structure of the universe. Moreover, this interplay between gravity and time reshapes our understanding of causality and the nature of events themselves. The intense gravity near a black hole not only slows time, but also distorts the way light travels, stretching and twisting the images of stars and galaxies behind it, creating gravitational lensing effects that reveal the invisible presence of these cosmic titans. Yet, time dilation is just one facet of the transformative power black holes exert on space-time. As matter and energy spiral inward, the environment around the black hole becomes a maelstrom of extreme physics. Radiation bursts, intense magnetic fields, and relativistic jets shooting out at near-light speeds. These phenomena offer a natural laboratory for testing the laws of physics under conditions impossible to replicate on Earth. This intricate dance between space, time, and gravity invites us to reconsider our place in the cosmos. Black holes are not just cosmic vacuum cleaners, but gateways to new realms of understanding. They challenge us to expand our theoretical frameworks, to develop new mathematics, and to innovate technologies capable of peering deeper into the universe's mysteries. In contemplating these cosmic wonders, we confront not only the limits of physics, but also the boundless reach of human imagination and perseverance. The story of black holes, woven with threads of curiosity and audacity, continues to inspire generations of scientists and dreamers alike, beckoning us to journey ever further into the great cosmic unknown. This tantalizing effect of time dilation near black holes has fueled a rich vein of speculation and imagination about the possibility of time travel. Scientists and science fiction enthusiasts alike have pondered whether the extreme warping of space-time caused by these cosmic giants might one day enable journeys to the past or future. If gravity can bend the flow of time itself, could advanced civilizations manipulate these forces to create portals or pathways that transcend ordinary temporal boundaries? Theoretical physicists explore concepts like wormholes, hypothetical tunnels through the fabric of space-time. that could, in principle, connect distant points not just in space, but also in time. Such ideas, while speculative, push the boundaries of our understanding and inspire us to dream beyond the constraints of everyday experience. However, the awe-inspiring allure of black holes is paralleled by the grave dangers lurking near their edges. At the heart of these perils lies the event horizon, the invisible boundary that marks the point of no return. Crossing this threshold means permanent capture by the black hole's gravitational clutch, a fate from which escape is impossible. The forces at play near the event horizon are so extraordinarily powerful that they challenge our very notions of matter and stability. One of the most terrifying aspects of this region is the intense gravitational tidal forces, sometimes referred to as spaghettification. As an object approaches the event horizon, the difference in gravitational pull between its nearest and farthest points becomes so extreme that it is stretched and torn apart like a piece of dough pulled thin. This violent process shreds any matter, from spacecraft to stars, into elemental particles in a spectacular cosmic display of destruction. This is not a slow or gentle event, but a dramatic and violent annihilation, underscoring the raw power and unforgiving nature of black holes. This harsh reality tempers the human fascination with black holes. While they captivate our imagination with their mysteries and theoretical possibilities, they also command our respect and caution. Black holes are natural phenomena where the laws of physics are pushed to their limits. Environments so extreme that they are inhospitable to any known form of life or technology. In this delicate balance between fascination and fear, black holes remind us of the grandeur and dangers of the universe. They challenge us to learn, to observe, and to respect the cosmic forces far beyond our everyday experience. As we continue to study and explore, we must navigate this boundary carefully, pushing the frontiers of knowledge while honoring the profound power of these celestial enigmas. Recognizing that our very existence is intricately intertwined with a universe that is at once breathtakingly beautiful and profoundly perilous, is to embrace both humility and curiosity. The cosmos around us is a vast, dynamic tapestry of forces and phenomena, from the gentle glow of distant stars to the violent pull of black holes, each telling a story of creation, transformation, and sometimes destruction. As humanity stands on the precipice of a new era in cosmic exploration, we find ourselves poised to journey into realms once thought inaccessible, pushing the boundaries of what we know and what we dare to imagine. Our voyage into the heart of black holes is emblematic of this grand endeavor. These enigmatic entities, with their unfathomable gravitational forces and mysterious interiors, challenge the very fabric of our understanding. They pose riddles that have confounded scientists for decades. What happens beyond the event horizon? Is time truly warped? Could these cosmic giants be gateways to other dimensions or universes? Each question beckons us forward, inviting us to expand the horizons of knowledge and to rethink the fundamental principles that govern reality itself. Yet, as we advance deeper into this uncharted frontier, it becomes ever clear that our pursuit must be tempered with caution. The immense power and complexity of the cosmos demand respect. Black holes are not mere curiosities or theoretical abstractions. They are violent and potent forces of nature whose effects ripple across space-time. Missteps in our understanding or approach could lead not only to scientific confusion, but to missed opportunities to learn vital truths about the universe and perhaps our own origins. Thus, this journey is as much about humility as it is about discovery. It reminds us that, despite our technological prowess and intellectual achievements, we remain a small part of an immense and ancient universe. To explore responsibly is to balance ambition with reverence, to push the frontiers of science while safeguarding the integrity of the cosmic fabric we seek to comprehend. In embracing this duality, our boundless curiosity and our deep respect for the cosmos, we honor both the spirit of exploration and the profound mysteries that lie ahead. It is this spirit that will guide humanity as we navigate the dark, captivating depths of black holes and continue to unravel the secrets of the universe. Ever mindful that with great discovery comes great responsibility, the destiny of Earth, our fragile blue oasis adrift in the vast ocean of the cosmos, lies far beyond the turbulent and unfathomable embrace of black holes. Those colossal celestial phenomena where the known laws of physics are stretched to their breaking point. These cosmic enigmas, with their immense gravitational pull and mysterious interiors, captivate the human imagination, inspiring both awe and caution. While their allure is undeniable, tempting us to explore realms beyond our current comprehension, we must remain grounded in the realities of our existence, cherishing the delicate balance that sustains life on our home planet. Earth is our sanctuary amid the cosmic wilderness, a place of vibrant ecosystems, intricate interdependencies, and histories that stretch back billions of years. Our immediate future, the fate of our species, and the continuation of life's diverse tapestry depend on how we nurture and protect this pale blue dot. As we reach outward toward the stars and contemplate the enigmas of black holes, we carry with us the responsibility to safeguard the world that cradles us, even as we seek to transcend it. In the magnificent and infinite tapestry of the cosmos, black holes reign as both profound marvels of nature and inscrutable mysteries that challenge the very fabric of our understanding. These celestial titans, born from the cataclysmic deaths of massive stars and reigning at the centers of galaxies, embody the extremes of physical law and the boundaries of human knowledge. Their existence invites us to embark on a journey of discovery that goes far beyond our terrestrial limits, a quest that stretches across the uncharted expanses of space and time. Our pursuit of knowledge about black holes and other cosmic phenomena is a testament to the boundless curiosity that defines humanity. It is an expression of our relentless drive to explore, to innovate, and to push the frontiers of what is possible. This quest has propelled generations of scientists, thinkers, and dreamers to develop sophisticated instruments and revolutionary theories, tools that allow us to peer into the darkest corners of the universe and glimpse the dance of gravity and light on scales both immense and infinitesimal. As we delve ever deeper into the cosmic abyss, seeking to unravel the secrets that black holes conceal, we participate in an odyssey that transcends the limits of any single lifetime or civilization. This ongoing voyage of exploration and discovery offers more than scientific insight. It promises a profound connection to the universe itself. Each revelation enriches our understanding of the cosmos's origins, its evolution, and the fundamental laws that govern all matter and energy. Beyond the realm of pure science, the mysteries of black holes challenge us to reflect on our place in the universe, our significance and fragility. These cosmic abysses symbolize both the unknown and the potential for transcendence, reminding us that the quest for understanding is inseparable from the spirit of wonder and humility. They invite us to contemplate profound questions about time, space, and existence itself, encouraging us to expand our perspectives and embrace the awe-inspiring vastness that surrounds us. As we stand at the precipice of new cosmic horizons, let us advance with a spirit of reverence and responsibility. The power and complexity of the universe demand both courage and caution. The mysteries we uncover must inspire not only scientific progress, but also a renewed commitment to preserving the precious life that thrives on Earth. Our exploration of black holes and the wider cosmos is not merely an intellectual pursuit. It is a journey that connects us to the deepest truths of existence and the enduring human spirit. The journey continues, an infinite odyssey through space and time, inviting us to explore the unknown, challenge the boundaries of knowledge, and discover the extraordinary within the vastness of the universe. As we voyage into the cosmic night, may we do so with open hearts, keen minds, and an unwavering dedication to the preservation and flourishing of life, here and beyond. Through the boundless realms of space and time, where the infinite expanse of the cosmos stretches beyond imagination, black holes emerge as enigmatic sentinels, cosmic gateways that beckon with the irresistible allure of revelation and the profound thrill of venturing into the unknown. These mysterious titans of gravity stand as both barriers and bridges, inviting humanity to embark on a transformative voyage that promises not only to challenge, but to fundamentally reshape our deepest understanding of reality itself. As we journey toward these dark abysses, we step beyond the familiar confines of classical physics and into a domain where the fabric of space-time warps and twists in extraordinary ways. Here, the known laws falter, and new possibilities arise. Possibilities that hint at answers to some of the most profound questions ever posed by science and philosophy. What is the true nature of space and time? Can we unravel the secrets of the singularity, where matter and energy collapse into a point of infinite density? Are there pathways through the cosmos, hidden within the curvature of space-time, that could link distant regions or even parallel universes? This voyage is far more than an exploration of distant phenomena. It is an odyssey that challenges the very foundations of human knowledge and perception. It calls us to reconsider what we know about the universe and our place within it, encouraging us to embrace uncertainty and marvel at the mysteries that lie just beyond the veil of comprehension. The journey toward black holes symbolizes humanity's insatiable curiosity, its unyielding desire to push beyond boundaries, and its enduring hope to find meaning in the vast cosmic ocean. With every discovery and insight gained from studying these celestial enigmas, we inch closer to unlocking secrets that could revolutionize technology, physics, and even our philosophical worldview. The allure of black holes is not just in their destructive power, but in their potential to illuminate the hidden architecture of the universe and the very essence of existence. Thus, as black holes beckon us forward, they do so with a promise of revelation, transformation, and the exhilaration of the unknown. They invite us not only to witness the marvels of the cosmos, but to become active participants in a grand cosmic narrative, one that stretches through space and time, challenging us to expand our horizons, transcend limitations, and journey toward a deeper, more profound understanding of reality itself. In the boundless expanse of space, a presence of profound mystery and wonder emerged, captivating our collective imagination and perplexing scientists scattered across the globe. This cosmic enigma, an interstellar object unlike any seen before, seemed to defy every known law of astrophysics. It moved with a velocity unbound by our solar system's gravitational leash, and bore characteristics that puzzled even the most seasoned astronomers. From the moment it entered our view, this celestial wanderer, later named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, became the center of scientific fascination and debate. Its trajectory indicated an origin beyond our solar system, marking the first known interstellar object to pass through. But it wasn't just its origin that intrigued experts. It was everything about it. It was long and narrow, unlike any comet or asteroid previously documented. It lacked a visible tail of gas or dust, traits expected from a comet. Yet it accelerated in ways that suggested forces beyond gravity were acting upon it. Was it a rogue asteroid? A comet without a tail? Or something far more extraordinary? As telescopes across Earth turned to the skies, capturing fleeting glimpses before it vanished into the darkness, the mystery deepened. The scientific community raced to explain its erratic movement and strange shape. Theories ranged from exotic natural formations to more provocative possibilities like alien technology, a light sail or probe from another civilization. Yet while the brightest minds of the scientific community struggled to fathom the nature of this interstellar anomaly, something even more profound was on the horizon, a pivotal shift in how we view the universe. Umu was not merely a space rock, it was a cosmic message, a wake-up call that our place in the universe is not as isolated as we once believed. Its arrival reminded us that space is not static. It is dynamic, full of surprises, and teeming with phenomena that challenge our understanding of reality. As we continue to search the skies for signs of similar visitors, the legacy of Oumuamua endures as a harbinger of the unknown and a testament to the enduring quest to answer one of humanity's greatest questions: are we truly alone in the universe? The momentous advent of NASA's James Webb Space Telescope, JWST, marked a turning point in our quest to understand one of the most compelling cosmic mysteries of our time. Heralded as the most powerful space observatory ever constructed, the JWST was designed to peer deeper into the universe than any telescope before it, capable of detecting the faintest whispers of light from galaxies billions of years old. But alongside its grand mission of unlocking the secrets of the early universe, it also offered humanity a unique opportunity to revisit the enigmatic visitor that had slipped through our solar system. Oumuamua, with its cutting-edge technology featuring a 6.5-meter gold-coated mirror and highly sensitive infrared instruments, the JWST represented the pinnacle of human ingenuity. Its deployment into space was a feat of precision and patience, unfolding over weeks like a cosmic origami in zero gravity. Once fully operational, its gaze turned not only to the distant past of the universe, but also to the mysteries that had recently crossed our own galactic doorstep. Oumuamua had left behind more questions than answers. It had long vanished into the dark beyond the reach of Hubble or any ground-based telescope. But JWST's instruments were more than just eyes. They were archaeological tools for cosmic history. Through a combination of advanced tracking data, simulation models, and deep sky observations, scientists used JWST to extrapolate details that had previously evaded every other telescope. Then came the moment. From the intricate web of data and imagery, a revelation emerged. A reconstructed view of Oumuamua, one grounded not in speculation, but in cutting-edge observation. For the first time, humanity glimpsed a true depiction of the interstellar traveler, not as a vague blur, but as a detailed celestial object. Its elongated shape was confirmed, its composition better understood, and its behavior now more clearly modeled. This new image, and the science behind it, did not just illuminate the story of a single interstellar object, it expanded the narrative of our universe. The JWST had provided proof that such visitors were real, tangible, and perhaps not as rare as once believed. But Oumuamua was no longer a ghostly blur from a distant star system. It was now a defined character in the unfolding story of cosmic exploration. And yet, the mystery was not entirely solved. Even with JWST's incredible clarity, questions still lingered. Why did it accelerate the way it did? What was its exact composition? Was it a natural fragment of an alien world, or something far stranger? As JWST continues to survey the cosmos, its revelations remind us that the universe is not just a silent expanse, it is a storyteller. Each star, each galaxy, and each interstellar visitor carries a message, waiting to be heard by those willing to listen. The story of Oumuamua, illuminated by the brilliance of JWST, is a profound reminder that we are at the very beginning of understanding what lies beyond. But what was it truly? Could it be that this enigmatic visitor from the distant reaches of the cosmos was not merely a chunk of rock or ice, but something more? A harbinger of an otherworldly origin, as a bold few in the scientific community dared to propose? This question, teetering between the boundaries of science and speculation, invites us on a journey unlike any other. A journey that doesn't just studies the stars, it challenges the very foundation of how we define the universe and our place within it. To gaze upon Oumuamua is to peer into a cosmic riddle wrapped in starlight. It arrived silently, without warning, hurtling through our solar system at a speed and trajectory that defied conventional celestial mechanics. Its shape, long, narrow, and eerily cigar-like, was unlike anything we've ever observed. Its motion, too, baffled experts. It accelerated away from the sun without any visible outgassing or tail, a behavior inconsistent with comets, asteroids, or any known natural body. This anomaly sparked whispers. Could it be artificial? Among those captivated by this mystery was Harvard astrophysicist Avi Loeb, who famously posited that Oumuamua might be a piece of alien technology, a light sail perhaps designed by an intelligent civilization to traverse interstellar distances. To many, this theory was outrageous. To others, it was exhilarating. After all, should we not remain open to the extraordinary when faced with the unexplained? This line of inquiry propels us deeper into the voyage of cosmic discovery. Not only do we examine the object itself, but we are also compelled to examine our assumptions. What if our definitions are too narrow, our expectations too limited? What if the universe is not only more vast and more ancient than we imagined, but more populated? As we traverse this intellectual and scientific frontier, we find our perceptions bending under the weight of possibility. Oumuamua becomes more than a visitor. It becomes a mirror, reflecting our hopes, fears, and deepest curiosities about what or who might be out there. Perhaps it was merely a natural interstellar shard shaped by forces unknown to us. Or perhaps it was a relic, a derelict probe from a civilization so far advanced that we cannot yet comprehend its purpose or origin. The truth remains elusive, dancing just beyond the reach of our instruments and our current understanding. Yet in its wake, Oumuamua left something powerful, a question. And it is in asking this question, without fear, without cynicism, that we affirm one of humanity's most beautiful traits, our boundless curiosity. We are not merely content to observe the universe, we seek to understand it, even when that understanding requires us to step into realms of wonder that border on the mythic. In the silence of space, Oumuamua whispered a message to us, a message not written in language, but in motion, form, and mystery. And as we unravel its intergalactic puzzle, we find ourselves not just looking outward, but inward, rethinking who we are, what we believe, and how far we're willing to go in pursuit of the unknown. This is not just a story about an object that passed through our sky. It is a story about us and the infinite universe that beckons us forward. Dimension of cosmic understanding creaked open. Oumuamua, named after the Hawaiian term meaning a messenger from afar arriving first, was no ordinary object. It raced through our solar system at a velocity that defied conventional classification, a silent harbinger of secrets written in the language of stars and time. Scientists scrambled to decipher its origin, composition, and trajectory, piecing together data with urgency and awe. This was not merely a flyby. It was an encounter, a fleeting brush with something ancient and untamed, forged in the dark interstellar abyss. Unlike any asteroid or comet ever recorded, Oumuamua exhibited no coma, no tail, no typical signs of outgassing. Yet it accelerated as if nudged by an invisible hand. The implications were staggering. Either our models of celestial dynamics were incomplete, or this object was propelled by mechanisms previously unknown, or perhaps unnaturally designed. And so began one of the greatest scientific puzzles of the 21st century. What was this elongated wanderer glinting as it spun through space, reflecting sunlight in strange and variable ways? Its brightness fluctuated dramatically, suggesting an object tumbling through space in an uncontrolled rotation. Yet, unlike any rock from our solar system, its shape and motion hinted at an origin utterly foreign. As telescopes across the globe turned toward this mysterious interloper, it became clear that time was against us. Oumuamua was already racing away from the inner solar system, its moment of closest approach already past. The window to observe and understand it was closing fast. Still, in those precious weeks, astronomers gathered what data they could, chasing an enigma that had traveled for millions, perhaps billions of years, only to spend a fleeting few weeks under human scrutiny. What made it even more profound was this. Oumuamua was the first of its kind ever detected. Never before had we directly observed an object from another star system entering our own. The universe had spoken, and we had just begun to listen. Speculations abounded. Was it a fragment of a shattered exoplanet, flung into the void by a celestial cataclysm? A cosmic iceberg of exotic ices, shedding invisible hydrogen as it neared our sun? Or could it be something else? A remnant of an ancient civilization? A probe designed not to communicate, but to observe, silently, efficiently, then move on? While the scientific community leaned toward natural explanations, even the most conservative models struggled to account for all of Oumuamua's oddities. The debate raged on, papers were published, conferences convened, and always the object itself drifted farther and farther away, shrinking into a pinpoint of light, then fading beyond the reach of our most powerful instruments. But its legacy endures. Oumuamua awakens something profound, a realization that our solar system is not isolated, that the void between stars is not empty, and that we are part of a far greater cosmic story than we had ever imagined. In its wake, humanity found renewed purpose. Plans were drafted to launch intercept missions for future interstellar objects. Instruments were refined, strategies reshaped, and minds inspired. If another messenger comes, we'll be ready, not just to observe, but to follow, to reach, perhaps even to touch. And so, the celestial saga of Oumuamua marks not an end, but a beginning, a call to lift our eyes skyward with fresh wonder, a whisper from the stars that says, we are not alone in this cosmic ocean, and the journey has only just begun. And with it, hope surged anew. Though Oumuamua was fast receding into the void, the James Webb Space Telescope, JWST, brought with it capabilities unlike any observational instrument before it. Designed to peer deeper into the universe than ever before, JWST was not merely a telescope, it was humanity's eye into the ancient past and the distant and now, the eye turned toward a singular, vanishing point in our cosmic periphery. With each second that passed, Oumuamua moved further away, fainter, more elusive, and shrouded in mystery. Yet the infrared capabilities of JWST allowed scientists to probe for subtle thermal signatures, offering clues that visible light could never reveal. Data streamed back, complex, rich, mysterious. Every spectrographic line, every pixel captured by JWST's detectors held the potential to rewrite what we knew, or thought we knew. About what was it made of? Was there outgassing? Did it behave like a comet cloaked in unfamiliar ices? Or was its propulsion due to something more exotic? Perhaps a structure so thin and light it rode on solar radiation, like a cosmic sail. Theories blossomed as the data trickled in, ranging from the conservative to the spectacular. Some suggested it was a fragment of a Pluto-like exoplanet, with an icy composition of hydrogen that evaporated invisibly in sunlight, giving it the strange acceleration observed. Others posited more radical ideas. A light sail of artificial design, crafted by an alien intelligence and sent across the stars on a silent reconnaissance. Whatever its nature, Oumuamua had become a celestial catalyst, igniting a renaissance in interstellar science. NASA and space agencies across the world began envisioning missions specifically designed to intercept future interstellar visitors. Missions that could launch on a moment's notice, outfitted with the tools to analyze, capture, or even return samples. The shockwaves that Oumuamua sent rippling through the scientific community continued to resonate. It shattered assumptions about the frequency of interstellar visitors, once considered nearly impossible to detect, now seen as inevitable. And with new surveys like the Vera C. Rubin Observatory and missions such as ESA's Comet Interceptor on the horizon, we stand ready to meet the next cosmic nomad. But Oumuamua's greatest legacy may not lie in its composition or trajectory, but in the questions it forced us to ask. How many other interstellar travelers pass through our solar system unnoticed? What secrets do they carry? Ancient histories of alien worlds, or the whisper of civilizations unknown? And perhaps most poignantly, What else is out there, waiting to be discovered? In the quiet that followed Oumuamura's departure, humanity was left with more than just mystery. We were left with purpose, a renewed sense of exploration, a deepened thirst for knowledge, and a profound understanding that we are not isolated specks in a cold void, but participants in a vast and dynamic universe, where messages may arrive on trajectories not written by human hands. And next time, we will be ready. With its state-of-the-art instruments, the James Webb Space Telescope, JWST, emerged not just as an observational tool, but as a technological sentinel tirelessly watching the celestial horizon. This marvel of engineering granted humanity unprecedented access to the hidden secrets concealed within the universe's most enigmatic wanderers. For the first time in history, we had a window not merely to observe, but to truly understand. More than a telescope, JWST became a bridge between worlds, a cosmic conduit linking Earth's curious minds to the vast and ancient corners of the cosmos. With its unmatched sensitivity to infrared light, it pierced through veils of cosmic dust, unveiling stars in their infancy, galaxies at the edge of time, and interstellar visitors like Oumuamua, whose mystery had long evaded clarity. Every photon it captured carried a message from across time, some billions of years old, now decoded by JWST's precision instruments. It transformed faint flickers of distant objects into vivid portraits, each pixel enriched with the story of a star's birth, a planet's atmosphere, or a foreign object passing silently through our solar system. As the telescope's golden mirrors aligned and its cryogenic instruments hummed in harmony, JWST did more than observe. It wove together a living tapestry of the cosmos. These weren't just images, they were histories, futures, possibilities, an atlas of the unseen, stitched together in infrared brilliance. And as its lenses focused and its detectors recorded the light of ancient and alien realms, it felt as though the telescope itself were a cosmic traveler, embarking on an odyssey not through space but through knowledge. Each revelation brought us closer to understanding the grand design of the universe, revealing that behind every shadow lies a story waiting to be told. In the silent vacuum of space, JWST speaks for us, asks for us, seeking answers to the greatest questions ever posed. Thus, the James Webb Space Telescope is not just a machine, it is our ambassador to the infinite, a shining testament to human curiosity, collaboration, and our unyielding desire to explore the unknown. As interstellar objects danced within the focused gaze of the James Webb Space Telescope, JWST, their faintest whispers of light, once elusive and invisible to the naked eye, were brought to life with breathtaking clarity. Structures that were once shrouded in cosmic obscurity now emerged like brushstrokes on a galactic canvas, revealing intricate details and previously undetectable features. What was once the stuff of speculation became visible reality. The JWST's advanced infrared sensors transcended the limits of Earthbound observation. Free from atmospheric distortion, it observed the cosmos from the cold stillness of space, offering humanity an unfiltered lens into the secrets of the universe. With each carefully calibrated movement, the telescope captured gigantic mosaics stitched from thousands of smaller images, creating mega-images that encapsulated the full essence of celestial wanderers like Oumuamua and other deep space anomalies. This was more than mere observation. It was a symphony of technology, a harmonious blend of cutting-edge engineering and the natural splendor of the universe itself. Every data packet sent back to Earth echoed with the brilliance of human ingenuity. Whispering stories of stars, comets, and interstellar visitors written in photons across time. Yet, while the James Webb Space Telescope basks in the glow of its revolutionary achievements, it is crucial to recognize the remarkable contributions of its terrestrial predecessor, the Pan-STARRS 1 telescope. Perched atop Haleakala volcano in Hawaii, the Panoramic Survey Telescope and Rapid Response System, Pan-STARRS 1, was the first to lay eyes upon the mysterious visitor Oumuamua on October 19, 2017. It was this ground-based marvel, designed for wide-field imaging of the night sky, that first detected the anomaly traveling at an extraordinary speed from beyond our solar system. In doing so, Pan-STARRS 1 etched its name into scientific history as the instrument that opened humanity's eyes to the existence of interstellar objects passing through our cosmic backyard. Without Pan-STARRS 1, there would have been no discovery, no intrigue, no international rush to understand the nature of this silent voyager. The telescope's constant vigilance and high-resolution surveys of the heavens made it the unsung hero of one of the most important astronomical discoveries of the century. Together, JWST and Pan-STARRS 1 represent two ends of a grand continuum, one scouting the skies, the other peering deep into the soul of the universe. Their combined legacy is a testament to global scientific collaboration, where earthbound observers and spacefaring instruments work in unison to decode the language of the cosmos. As more celestial messengers like Oumuamua arrive, carried by the tide of interstellar space, these remarkable instruments ensure that we are watching, waiting, and ready to understand. Perched atop the majestic summit of Haleakala in Maui, Hawaii, the Pan-STARRS 1 telescope rose not just as an instrument of science, but as a beacon of human brilliance, perseverance, and global collaboration. Its silhouette against the starlit sky is more than picturesque. It represents the collective ambition of humankind to understand the universe and protect our home within it. This visionary endeavor was the result of a unified effort among prestigious institutions. The University of Hawaii's Institute for Astronomy, the MIT Lincoln Laboratory, the Maui High Performance Computing Center, and Science Applications International Corporation, SAIC. Together, they gave life to the Pan-STARRS project, a mission conceived not just to observe, but to actively monitor and decode the ever-shifting tapestry of the night sky. With its 1.8-meter diameter mirror, Pan-STARRS 1, short for Panoramic Survey Telescope and Rapid Response System, was designed for wide-field imaging, capturing vast sections of the night sky in a single frame. It became a celestial sentinel, continuously scanning the heavens with unmatched vigilance. It processed terabytes of data using advanced algorithms and high-performance computing systems, allowing it to identify subtle changes, new stars, asteroids, comets, supernovae, and most notably, interstellar objects. But its mission extended far beyond astronomical curiosity. Pan-STARRS 1 was also Earth's early warning system, a guardian scanning the cosmos for near-Earth objects, NEOs, including potentially hazardous asteroids. By identifying these objects early, Pan-STARRS has played a pivotal role in planetary defense, helping scientists track and assess potential threats long before they come close. Its most groundbreaking moment came in October 2017, when it detected Oumuamua, the first known interstellar object to visit our solar system. This moment was historic, not just for what it revealed, but for what it suggested, that our solar system is not an isolated island in space, but a junction of interstellar highways briefly visited by objects from distant star systems. And as humanity stood at the threshold of this revelation, Pan-STARRS 1 became not just a telescope, it became a symbol of discovery. Its lenses captured a visitor from the stars. Its sensors chronicled a mystery that would ripple across the global scientific community. And its success reminded us all that when innovation meets collaboration, even the deepest secrets of the cosmos can come into view. In an age where space remains the final frontier, Pan-STARRS 1 teaches us that vigilance, unity, and the thirst for knowledge can bring light to the darkest corners of our universe, the gravitational norms of our solar system sparking intense debate among astronomers, astrophysicists, and theorists alike. It didn't just pass through. Oumuamua pierced the very fabric of scientific understanding, raising questions that echoed far beyond its fleeting visit. Unlike the icy comets and rocky asteroids familiar to us, Oumuamua bore no glowing coma, no tail of vaporized gas, traits typical of such visitors. Instead, its dry, tumbling, cigar-shaped body, estimated to be about 800 meters in length and only 80 meters wide, spun chaotically as it sailed through the inner solar system. This motion, irregular and unbound, suggested a non-gravitational acceleration, a puzzling propulsion not easily explained by the known forces acting upon it. Its reddish hue, revealed by spectral analysis, hinted at cosmic weathering, surface alteration due to countless years exposed to interstellar radiation. This coating, more than a color, was a chronicle, a timeline of Oumuamua's ancient voyage across the stars, possibly spanning millions of years. But it was the unexpected acceleration, a subtle yet undeniable increase in its speed as it exited the solar system that set the scientific world abuzz. This anomaly couldn't be attributed to gravitational slingshots or known gas emissions. No visible signs of outgassing, which typically propel comets, were observed. This forced researchers to consider more exotic possibilities. Some proposed that Oumuamua could be composed of pure hydrogen ice, allowing invisible sublimation to push it forward. Others speculated about the possibility of light sail propulsion, a concept involving a thin reflective structure propelled by radiation pressure, suggesting the remote possibility of an artificial origin. Harvard astronomer Avi Loeb famously fueled the debate by suggesting that Oumuamua might be a fragment of advanced extraterrestrial technology, perhaps a derelict probe or a piece of alien engineering, an interstellar relic drifting silently through space. While this theory remains controversial and unproven, it invigorated public imagination and highlighted the importance of remaining open to the unknown in scientific inquiry. Ultimately, Oumuamua was with us only briefly. After just 11 days of high-quality observation, it faded from reach, racing away from our sun and leaving more questions than answers. Yet in that short window, it changed the way we look at the universe. It reminded us that the cosmos is not static, that visitors from distant stars are not only possible, but real. It reignited our passion for discovery and exposed the limits of our current scientific models, urging us to refine our tools, rethink our theories, and remain ever vigilant. As the journey through Oumuamua's story continues, it becomes more than a tale of a wandering rock. It becomes a cosmic message in a bottle, drifting through the void, inviting us to read between the stars. Oumuamua is not just a mere object drifting aimlessly through space. It is a celestial enigma, a cosmic wanderer whose very existence challenges our understanding of the universe. Its behavior, a complex choreography shaped by gravitational forces and other unseen influences, whispers secrets about the hidden mechanics and subtle interactions that govern the vast cosmic stage. Amid the many theories proposed to explain Oumuamua peculiarities, one idea stands out as particularly compelling and grounded in astrophysical reasoning. The notion that Oumuamua is not an isolated wanderer born in solitude, but rather a fragment torn from a much larger celestial body. Imagine a violent cataclysmic event, perhaps the explosive collision of massive objects, or a gravitational dance gone awry, powerful enough to rip apart a star system's structure. From this colossal cosmic upheaval, shards are hurled forth, propelled across the vast interstellar void. Oumuamua, then, is one such fragment, cast into the void with tremendous velocity, journeying across millions of years and light years to arrive in our solar system. This perspective paints the interstellar space as a dynamic, ever-evolving tapestry, filled with remnants and relics of cosmic cataclysms, a celestial landscape where unexpected visitors can appear without warning. Each fragment, like Oumuamua, carries a story, a history etched into its shape, composition, and trajectory. In this grand theatre of cosmic exploration, Oumuamua's enigmatic nature fuels our fascination and curiosity, reminding us that the universe is full of surprises and that our quest to comprehend it is a never-ending saga. It beckons us to reflect on the mysteries still hidden beyond our current scientific horizons and invites us to ponder profound questions about the origins and fate of matter traveling between the stars. The story of Oumuamua remains an ongoing cosmic narrative, encouraging humanity to look up, to keep searching, and to embrace the unknown with both wonder and scientific rigor. The mysteries that shroud our universe often seem impenetrable, veiled in darkness, scattered across the endless cosmic ocean. Yet time and again, human ingenuity and insatiable curiosity illuminate these shadows, revealing new chapters of the grand cosmic story. At the forefront of this quest stands the James Webb Space Telescope, a magnificent beacon of scientific advancement and a symbol of humanity's relentless thirst for knowledge. This marvel of technology, with its unprecedented sensitivity and power, is poised to rewrite our understanding of Oumuamua, the elusive celestial traveler that has captivated the world's imagination. As its sophisticated instruments hone in on the faint whispers of infrared light emitted from Oumuamua's surface, the telescope unravels details about its composition, origins, and enigmatic purpose, details once lost in the vastness of space. With each photon captured, the Webb Space Telescope pierces deeper into the secrets of this cosmic visitor, peeling back layers of mystery that have confounded scientists and stirred wonder in equal measure. It promises to unveil truths that challenge our wildest imaginations, truths that may reshape our cosmic perspective and push the boundaries of what we consider possible. As we stand on the precipice of this new era of enlightenment, ready to embrace revelations that may forever alter our understanding of the universe, Oumuamua's story becomes more than a tale of an interstellar object. It becomes a testament to human perseverance, collaboration, and the unquenchable flame of curiosity that drives us to explore beyond the horizons of the known. The journey into Oumuamua's mystery transcends scientific inquiry. It is a profound invitation to expand our minds and open our hearts to the awe-inspiring wonders that lie beyond our world. As the James Webb Space Telescope prepares to unlock the cosmic secrets hidden in the depths of space and time, we find ourselves on the cusp of discovery, poised to encounter the wondrous, the unexpected, and the truly extraordinary. In this mind-bending cosmic odyssey, we are reminded that exploration is not merely about answers, but about embracing the unknown with courage and wonder. It is a voyage that unites us all in the shared human experience of seeking, learning, and marveling at the vast, beautiful universe we call home. In the vast, dark silence that lies between the stars, a lone emissary from Earth continues its timeless journey, NASA's Voyager 1 spacecraft, a symbol of human curiosity and ambition. Launched in 1977, Voyager 1 was part of an extraordinary mission that would go on to define an era in space exploration. Together with its twin, Voyager 2, it was built to explore the outer planets. But what it ultimately achieved surpassed every expectation. The Voyager missions marked a watershed moment in the history of space science. Designed initially to conduct close-up studies of Jupiter and Saturn, these pioneering probes delivered breathtaking images and unprecedented data, transforming our understanding of the gas giants and their moons. Yet, even as Voyager 1 completed its original mission, it kept going, pushed onward by the relentless drive of discovery embedded in its very design. Voyager 1's journey did not end at the edge of the solar system. Instead, it became the first man-made object to enter interstellar space, crossing the heliopause, the boundary where the solar wind gives way to the interstellar medium, on August 25, 2012. With this historic achievement, Voyager 1 stepped beyond the protective bubble of our sun's influence into a new and uncharted realm. It was a leap not just across space, but across the boundaries of human knowledge. As it travels more than 14 billion miles from Earth, Voyager 1 continues to send back signals, whispering secrets from a region of space no other human-made craft has ever visited. It relays vital information about cosmic rays, magnetic fields, and the density of interstellar plasma. Clues that help scientists piece together the nature of the space between stars. But Voyager's legacy is more than just data. It is also deeply philosophical and symbolic. Affixed to the spacecraft is the Golden Record, a phonograph containing sounds and images selected to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from across the world, and even the brainwaves of a young woman in love. This record is a message to the cosmos, a hopeful gesture that speaks to our species' longing to connect with whatever might lie beyond. In every sense, Voyager 1 is more than a spacecraft. It is a time capsule, a sentinel, and a storyteller. It has witnessed the auroras of Jupiter, the rings of Saturn, and now the strange silence of the interstellar deep. Its journey reminds us that exploration is not just about where we go, but what we learn about ourselves along the way. Even now, over 4 decades since its launch, Voyager 1 continues its odyssey, a tiny speck in a vast ocean, sailing ever farther into the unknown. It carries with it the dreams, questions, and hopes of a planet bound by gravity, but driven by imagination. As long as Voyager 1 speaks, even in the faintest signals, humanity is still out there, listening, learning, and reaching for the stars. Voyager 1, the unstoppable explorer, and a recent cosmic silence. Voyager 1's epic odyssey through our solar system and beyond is nothing short of legendary. Over the decades, this pioneering spacecraft has peeled back the veils of cosmic mystery, unveiling long-hidden secrets that have deepened our understanding of the universe. From the swirling storms of Jupiter to the icy rings of Saturn, Voyager 1 has offered us front-row seats to the most majestic sights in our solar neighborhood. But its greatest achievement lay ahead. When it crossed into interstellar space, Voyager 1 shattered the final frontier, becoming our first messenger to venture beyond the protective bubble of the sun's influence. And even now, more than 45 years after its launch, Voyager 1 continues to surprise us. Scientists across the globe are still interpreting the groundbreaking data it transmits, confirming new findings that have the potential to revolutionize astrophysics and reshape how we understand the cosmic environment that surrounds our solar system. Every byte of information sent back from this tiny spacecraft, now over 14 billion miles away, is a treasure trove for science. The legacy of the Voyager missions is monumental. They stand not just as triumphs of engineering and science, but as symbols of humanity's insatiable curiosity and unwavering desire to push boundaries. They are beacons of inspiration, reminding us that even the smallest emissaries can carry the weight of our greatest dreams. However, Voyager 1's journey has not been without challenges. Recently, the mission encountered a puzzling interruption. After decades of steady communication, the spacecraft began sending back distorted data to Earth, signals that confused even seasoned mission engineers. It appeared that Voyager 1's telemetry system, which reports on the status and health of the spacecraft, was malfunctioning. For a time, it was as if our voice in the stars had gone faint, as if a long-trusted friend had grown distant and unrecognizable. But in true Voyager spirit, the story didn't end there. The incredible team at NASA's Jet Propulsion Laboratory sprang into action, navigating decades-old software, ancient hardware, and limited resources to diagnose the issue. In a feat of modern-day engineering wizardry, they managed to recover, contact, and restore normal communication, once again proving that even across unimaginable distances, human ingenuity can bridge the void. So join us in today's video as we dive deep into the story of Voyager 1, its triumphs, its mysteries, and the remarkable resilience of both machine and mankind. From its humble beginnings on Earth to the farthest edge of the solar system, this is more than a mission. It's a journey into the very soul of what it means to be human. The stars still call, and Voyager 1 is still answering. Voyager's original mission, a leap into the unknown. When the Voyager mission was conceived in the early 1970s, it was nothing short of audacious, a daring leap into the unknown. The primary objective was ambitious: to collect detailed data on the 4 giant outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, through close-up exploration that had never before been attempted. At that time, these planets remained largely mysterious, distant orbs observed only through Earth-bound telescopes. Their complex systems of moons, magnetic fields, atmospheres, and potential ring structures were shrouded in uncertainty. Voyager was designed to change that forever. The mission sought to pull back the cosmic curtain, sending back high-resolution images and scientific measurements that would unravel the secrets of these colossal worlds. From the swirling storms of Jupiter to the elegant rings of Saturn, from the icy blue expanse of Uranus to the deep azure hues of Neptune, The Voyager spacecraft promised to deliver a view of the outer solar system unlike anything humanity had ever seen. But despite the excitement, skepticism loomed large. Many questioned whether the spacecraft could even survive the launch, let alone withstand the immense distances and harsh conditions of deep space. These concerns were far from unfounded. After all, no mission had ever attempted such an extensive voyage through the outer solar system. The journey would take years. The technology was untested on such a scale, and there were no guarantees of success. Fuel limitations, signal delays, mechanical failures. Any number of problems could have ended the mission prematurely. And yet, the team pressed on. Against the odds, Voyager 1 and its twin, Voyager 2, not only survived, they thrived. They conducted flawless flybys of the target planets, capturing images that astonished the world and collecting data that transformed planetary science. Thanks to Voyager, we discovered active volcanoes on Jupiter's moon Io, observed complex weather systems on Neptune, mapped intricate magnetic fields, and even detected unexpected ring systems around planets like Uranus. What was once theory became fact. What was once invisible became breathtakingly real. In hindsight, what seemed like a gamble turned into one of the greatest scientific triumphs in human history. And remarkably, the mission didn't end with the outer planets. Voyager's story was just beginning. Propelled by its own momentum, Voyager 1 journeyed on, setting its course for the stars. Today, it continues its odyssey in interstellar space, carrying with it a golden record, a message from Earth, a time capsule for any distant intelligence that might one day discover it. Voyager's triumph, a legacy of ingenuity and discovery. However, against all expectations and despite immense technical hurdles, the Voyager spacecraft defied all odds, embarking on an extraordinary odyssey of scientific exploration. An odyssey that continues to shape our understanding of the cosmos even to this day. Launched in 1977, Voyager 1 and Voyager 2 were more than just spacecraft. They were symbols of human ingenuity, resilience, and an insatiable thirst for discovery. At a time when direct data on the outer planets was scarce and only a handful of missions had ventured beyond Mars, Voyager dared to do the impossible. It pushed the boundaries of our planetary knowledge, becoming the first mission to provide close-up images and in-depth data on Jupiter, Saturn, Uranus and Neptune, forever transforming how we understand the gas and ice giants that inhabit the outer reaches of our solar system. Engineers and scientists faced enormous challenges. With no precedent for such a long and complex journey, obtaining precise measurements of distant planets, their atmospheres, rings and moons, was a formidable task. The vacuum of space, intense radiation belts, signal delays across billions of kilometers, these were just a few of the formidable obstacles the mission had to overcome. And yet, Voyager was ready. Both spacecraft were equipped with a suite of 11 advanced scientific instruments, each meticulously designed to capture different aspects of the planets and their environments. These included imaging systems for capturing detailed photographs of planets, moons and ring systems, infrared and ultraviolet spectrometers to analyze atmospheric composition and thermal radiation, magnetometers to measure magnetic fields, cosmic ray and plasma detectors to study solar wind and interstellar particles, photopolarimeters and radio science instruments to probe planetary densities and structures. With these tools, Voyager did far more than anyone expected. It discovered volcanoes erupting on Io, detected complex ring structures around all 4 outer planets, revealed the dynamic, storm-filled atmospheres of gas giants. The data returned by Voyager laid the groundwork for every outer solar system mission that followed, from Galileo and Cassini to Juno and beyond. More importantly, it ignited the public imagination, demonstrating that we are capable of reaching out across the vast emptiness of space, not just to see, but to understand. Voyager didn't just travel far, it changed everything we thought we knew about the outer solar system. Engineering the impossible, how Voyager defied the darkness of deep space. At the heart of the Voyager missions lies a symphony of sophisticated engineering and scientific ambition. Each probe, Voyager 1 and Voyager 2, was equipped with a suite of highly specialized instruments designed to explore the farthest frontiers of our solar system. These included photometers, magnetometers, cameras, charged particle detectors, radio antennas, and plasma detectors, each playing a crucial role in analyzing planetary environments, magnetic fields, radiation belts, and distant atmospheric phenomena. Yet, deploying this technology posed a monumental challenge. Operating sensitive instruments billions of kilometers away from the Sun in the cold, silent void of deep space was an unprecedented task. Unlike missions closer to Earth, Voyager could not rely on solar panels for energy, as the Sun's light was too faint to be of any practical use. To overcome this hurdle, NASA engineers turned to nuclear energy, harnessing the power of radioisotope thermoelectric generators, RTGs. A brilliant solution that would become the backbone of Voyager's longevity. Each spacecraft carried plutonium-238, a radioactive material whose natural decay produces heat. The RTGs ingeniously converted this heat into electricity, ensuring a steady, reliable power source that would function regardless of the spacecraft's distance from the Sun or the passing of decades. These compact power plants enabled Voyager's systems to remain operational even as they traversed the frozen frontiers of space, where temperatures plummet to hundreds of degrees below zero and sunlight is a distant memory. Each Voyager spacecraft carried approximately 722 kilograms of payload, comprising scientific instruments, communication systems, and power sources, all meticulously arranged to withstand the harsh rigors of space travel. The probes had to operate with extreme autonomy, capable of managing critical functions and making real-time decisions based on pre-programmed algorithms due to the immense communication delay with Earth. Thanks to this visionary engineering, the Voyager twins have transmitted invaluable data for over 4 decades. They have rewritten textbooks, uncovered new planetary phenomena, and extended the reach of human understanding into the interstellar medium, a realm no spacecraft had ever entered before. The story of Voyager is not only a triumph of science, but also a resounding testament to human creativity, problem-solving, and our determination to seek knowledge, no matter how distant the destination may be. Strategic precision: how NASA engineered the grand tour of the outer planets. Sending a spacecraft into the vast and unforgiving expanse of our solar system is no small feat, especially in the 1970s, when spaceflight technology was still in its relative infancy. The Voyager missions required not only remarkable engineering and endurance, but also strategic genius to ensure their success. One of the key challenges was power management. For the spacecraft to function efficiently and avoid aimless drifting through space, they required substantial and uninterrupted power. A task that NASA solved with the use of radioisotope thermoelectric generators. But generating power was only part of the equation. Planning the journey itself demanded equal brilliance. NASA's engineers meticulously charted the mission trajectories, utilizing an ingenious technique known as gravity assist, a maneuver in which a spacecraft uses the gravity of a planet to gain speed and alter its course. By harnessing the gravitational pull of Jupiter and Saturn, the Voyagers could be slingshotted farther into the solar system without expending extra fuel, allowing them to travel vast distances with remarkable efficiency. The timing of the mission was critical. In the late 1970s, the outer planets Jupiter, Saturn, Uranus, and Neptune were entering a rare favorable alignment that occurs only once every 176 years. This unique positioning allowed for what NASA called the Grand Tour, a chance to visit all 4 giant planets in a single mission, using consecutive gravity assists to propel the spacecraft from one planet to the next. Initially, NASA envisioned a single ambitious spacecraft to complete this entire tour. However, due to budgetary constraints and technical risks, the agency opted for a more cost-effective and flexible solution, launching 2 identical spacecraft, each with its own specific trajectory and mission goals. Thus, Voyager 1 and Voyager 2 were born. Voyager 1 was designated to fly by Jupiter and Saturn, getting close enough to study their atmospheres, moons, and rings in unprecedented detail. Voyager 2, meanwhile, was tasked with exploring all 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, becoming the only spacecraft in history to have visited all of them. Despite the limitations of 1970s technology, no GPS, no onboard AI, and minimal computer memory, NASA's planning left no stone unturned. Every trajectory calculation, communication schedule, and instrument command had to be programmed in advance with precision and foresight. There was no room for error in the dark and distant void. Against all odds, the Voyager mission persevered. What started as a bold idea evolved into one of the most iconic and enduring achievements in the history of space exploration. These spacecraft not only survived the journey, but also exceeded every expectation, becoming the longest operating and farthest traveling spacecraft humanity has ever launched. Voyager 1's encounter with Jupiter, a turning point in planetary science. When NASA launched the Voyager spacecraft, it did so with high hopes and bold ambitions, but much of what the mission might reveal remained rooted in optimistic speculation. At the time, the outer planets were enigmatic giants, their moons little more than distant, blurry dots captured in telescopic glimpses from Earth. Yet the Voyager mission pressed forward, determined to overcome the uncertainties and break through the boundaries of human understanding. In 1979, Voyager 1 reached Jupiter, the largest planet in our solar system. What unfolded during this flyby marked a historic turning point in planetary science. Among the many stunning revelations, one in particular captured the imagination of scientists around the globe. Jupiter's moon, Io, long thought to be just another rocky satellite, was found to be geologically active. This was a revolutionary discovery. Up to that point, Earth had been considered the only body in the solar system with active geology, volcanoes, tectonic movements, and internal heat flow. Io, smaller than Earth's moon and just a third the size of Earth, defied all expectations. Voyager 1 captured astonishing images of Io's surface, erupting volcanoes, shifting terrain, and widespread lava flows, revealing that this tiny moon was the most geologically active object in the entire system. Even more remarkable was the intensity of Io's activity. Despite its modest size, Io was generating twice as much internal heat as Earth. This immense energy output wasn't due to radioactive decay or solar heating, but rather the result of tidal heating, a process driven by the gravitational tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbited the gas giant, it experienced constant flexing, causing its interior to heat up dramatically and fuel continuous volcanic eruptions. The surface of Io, unlike anything seen before, was a vibrant mosaic of sulfurous plains, towering plumes, and lava lakes, with colors ranging from yellow and orange to red and black. Some volcanic plumes were found to erupt hundreds of kilometers into space, a spectacle that redefined scientists' understanding of how dynamic a moon's surface could be. This discovery alone would have been enough to cement the success of the Voyager program, but it was only the beginning. Voyager 1's findings at Jupiter, and particularly at Io, reshaped planetary science. It proved that geologic activity was not limited to Earth, opening the door to new theories about potential habitability on other moons, such as Europa, and later Enceladus and Titan. Voyager 1's flyby of Jupiter was more than a mission milestone. It was a moment that changed the way we look at the solar system. It reminded us that even the most unassuming celestial bodies could hold astonishing surprises, and it underscored the value of exploration, venturing into the unknown, driven by curiosity, only to discover realities far more wondrous than imagined. Voyager 1's discoveries at Jupiter, redefining planetary science. The Voyager 1 mission's close encounter with Jupiter didn't just provide breathtaking visuals of the largest planet in our solar system. It shattered long-held assumptions and revolutionized our understanding of gas giants and their complex systems. Among its most surprising revelations was the geologic dynamism of Io. But that was just the beginning. As Voyager 1 continued its flyby, it unveiled a tapestry of scientific findings that would forever change how we study the cosmos. One of the most unexpected discoveries was the enormity and strength of Jupiter's magnetosphere, the magnetic field that surrounds the planet. Previously, scientists had underestimated its scale, but Voyager 1 revealed that Jupiter's magnetosphere is the largest structure in the solar system, stretching outward until it nearly reached the orbit of Saturn, a distance of over 10 million kilometers. This discovery emphasized just how powerful Jupiter's magnetic influence is, affecting not only its own moons and rings, but also the solar wind far beyond what anyone had predicted. The probe's suite of instruments also penetrated the secrets of Jupiter's atmosphere. It analyzed the planet's composition in unprecedented detail, detecting a mix of hydrogen and helium, the primary elements as expected, but also traces of water vapor, methane, ammonia, and even rocky materials. These findings provided scientists with valuable clues about Jupiter's internal structure, formation history, and the dynamic processes taking place in its turbulent clouds. Through high-resolution imaging and data collection, Voyager 1 captured images of Jupiter's Great Red Spot, a massive storm that had already raged for centuries, and unveiled swirling cloud bands, chaotic atmospheric motions, and fast-moving jet streams. The planet's ever-changing weather systems, driven by internal heat and rapid rotation, painted a vivid picture of a world alive with activity, despite having no solid surface. Even more astonishing was what Voyager uncovered about Jupiter's moons. Not only Io, but Europa, Ganymede, and Callisto. Each of these Galilean satellites showed unique characteristics, from cracked icy surfaces to evidence of internal oceans, hinting at the possibility of subsurface water and even conditions suitable for life in the most unexpected places. These findings collectively expanded the scientific paradigm. Before Voyager 1, moons were often thought of as cold, inactive bodies, mere rocks orbiting planets. But now, they were seen as diverse and complex worlds, some with active volcanoes, hidden oceans, or mysterious terrain, each deserving of further exploration. Voyager 1's mission to Jupiter served as a powerful reminder. The solar system is far more intricate and alive than previously imagined. What started as a mission to collect data transformed into a voyage of revelation, deepening our understanding of planetary geology, atmospheric dynamics, and magnetic fields on a grand scale. This historic flyby didn't just enrich our scientific libraries, it sparked new questions and laid the foundation for future missions. It also inspired a generation of astronomers, engineers, and explorers to continue humanity's relentless pursuit of knowledge beyond Earth. Voyager's unprecedented discoveries, from Jupiter to Saturn. As Voyager 1 departed the realm of Jupiter, it left behind a treasure trove of discoveries that redefined planetary science. Yet, its journey was far from over. With unwavering precision, the spacecraft set its course for Saturn, the sixth planet from the Sun, and another celestial giant cloaked in mystery. But before we plunge into the wonders of Saturn, it's important to reflect on one final, critical chapter from Voyager's exploration of Jupiter: the unexpected discoveries surrounding its rings and moons. In a stunning revelation, Voyager 1 captured the first up-close image of a narrow, dark ring encircling Jupiter, a phenomenon that had eluded astronomers for decades. The ring's existence, previously undetected from Earth, was believed to be composed of fine dust particles, and possibly the remnants of an ancient moon pulverized by past collisions. This finding challenged assumptions that only Saturn possessed rings and opened a new frontier of inquiry into the dynamics of planetary ring systems. Additionally, Ganymede, Jupiter's largest moon and the largest in the entire solar system, came under intense scrutiny. Voyager 1's sophisticated instruments detected the presence of a tenuous atmosphere, an exosphere composed mostly of oxygen. This was a groundbreaking discovery. Up until then, Ganymede was considered geologically dead and atmosphereless. The existence of this thin atmosphere suggested internal activity and set the stage for later missions, such as the upcoming ESA's Jupiter Icy Moons Explorer, USH, and NASA's Europa Clipper. Together, these findings reshaped our understanding of Jupiter as not just a giant gaseous planet, but a complex system teeming with dynamic moons, active geology, hidden atmospheres, and mysterious rings. It was a microcosm of cosmic diversity, waiting to be studied for generations. Voyager 1, at Saturn, unveiling the secrets of the ringed giant. With its instruments still functioning optimally, Voyager 1 journeyed farther into the outer solar system, setting its sights on Saturn. Arriving in 1980, it encountered a world unlike any seen before, an ethereal planet adorned with breathtaking rings and home to one of the most intriguing moons in the solar system. Titan. Perhaps the most astonishing revelation of this leg of the mission was related to Titan, Saturn's largest moon. As Voyager 1 flew past it, scientists were astounded to discover that Titan's solid core had a smaller diameter than Ganymede, despite Titan being shrouded in a thick atmosphere that made it appear larger from afar. This challenged previously held beliefs and prompted a re-evaluation of how moons formed and evolved. The probe also revealed that Titan's dense atmosphere was primarily composed of nitrogen with traces of methane and complex hydrocarbons, an atmospheric makeup strikingly similar to that of early Earth. Although Voyager 1 was unable to see Titan's surface due to the thick orange haze, it provided strong evidence that liquid lakes or seas could exist beneath the clouds, paving the way for future missions like Cassini, Huygens, which later confirmed the existence of methane lakes. Moreover, Voyager 1's approach offered unprecedented views of Saturn's rings. What once seemed like uniform bands through telescopes were now revealed to be composed of thousands of smaller ringlets, each a delicate structure of ice and rock particles, ranging from microscopic grains to large boulders. The rings displayed intricate wave patterns caused by the gravitational influence of Saturn's moons, adding yet another layer of complexity to the planet's environment. The spacecraft also identified several previously unknown moons orbiting Saturn and revealed intricate magnetic and radiation belts that hinted at dynamic processes happening deep within the gas giant's core. A legacy of discovery. The discoveries made by Voyager 1 at Jupiter and Saturn were more than just data points. They were revelations that forever altered our perception of the solar system. Each encounter unveiled phenomena that defied expectations, challenged theories, and inspired countless new questions. By capturing stunning visuals, analyzing complex atmospheric compositions, uncovering geologic activity and mapping planetary magnetospheres, Voyager 1 expanded the frontier of human knowledge. Its journey stands not only as a testament to human ingenuity and curiosity, but as a gateway to understanding our place in the vast cosmos. And yet, the Voyager story doesn't end at Saturn. As the probe moved beyond the gravitational grip of our major planets, it ventured into a new and uncharted domain, interstellar space. Becoming the first human-made object to do so, the Voyager missions unveiled the magnificent moons of Saturn in unprecedented ways, providing invaluable data that continues to fuel scientific research decades later. These missions stand as a towering testament to human ingenuity and the unquenchable thirst for exploration and discovery. Voyager's meticulous exploration of Saturn marked a significant milestone, unearthing astonishing findings about our nearest gas giant neighbor. Despite Saturn being one of the most studied planets in our solar system, the mission revealed that even worlds we think we understand can still harbor unexpected surprises. These discoveries remind us that close, detailed examination often uncovers hidden complexities that reshape our understanding. While the Voyager probes gathered a wealth of information during their initial flybys, their journey did not end there. As they continued on their path toward interstellar space, the probes presented scientists with a unique opportunity to delve even deeper into the nature of these planets and their surroundings. Through detailed investigations, the Voyager spacecraft revealed new phenomena, expanding our knowledge far beyond what was previously imagined and setting the stage for future exploration of the outer solar system. With meticulous data collection and thorough analysis, the Voyager missions provided scientists with a deeper understanding of Saturn's atmosphere, magnetosphere, rings, and moons. The probes uncovered new and intricate features, such as complex ring structures, dynamic storm systems, and previously unknown atmospheric phenomena. These findings dramatically expanded our comprehension of this gas giant, revealing its secrets in ways that had once seemed unimaginable. The wealth of data gathered from Voyage's in-depth studies not only enriched our knowledge of Saturn, but also deepened our broader understanding of the outer solar system. These missions continually fuel human curiosity and the drive for exploration, standing as a powerful testament to human ingenuity and our relentless pursuit of cosmic knowledge. Voyager probes are forever remembered as pioneering endeavors that broadened humanity's horizons and unlocked new mysteries within the universe. In a groundbreaking announcement in February 2023, astronomers revealed an astonishing new discovery. They had identified 12 new moons orbiting Jupiter, bringing the total confirmed number of moons around the gas giant to an unprecedented 92. This remarkable finding highlights that even decades after the Voyager missions, the outer planets continue to surprise and captivate us, offering endless opportunities for discovery. This extraordinary discovery firmly establishes Jupiter as the planet with the highest number of natural satellites in our solar system, surpassing the previous record held by Saturn, which has 83 moons. The dozen newly identified moons were detected and carefully observed using advanced telescopes located in Chile and Hawaii during 2021 and 2022. Following meticulous data collection and rigorous analysis, the discovery was officially confirmed in 2023. This remarkable finding adds significant depth to our ever-growing understanding of the complex and dynamic Jovian system, offering new insights into the intricate gravitational ballet performed by the numerous moons orbiting this massive gas giant. It also highlights the continuous advancements in astronomical observations and reflects humanity's unrelenting curiosity to explore and unravel the mysteries of the cosmos. After their initial detection, the orbits of these new satellites were meticulously tracked and confirmed through extensive follow-up observations conducted by a dedicated team of scientists. This further in-depth analysis has not only validated their existence, but also helped refine our knowledge of their orbital characteristics, stability, and interactions within Jupiter's vast gravitational influence. The discovery of these moons serves as a reminder that despite centuries of astronomical study, our solar system continues to hold surprises, and each new revelation brings us closer to understanding the full complexity of the cosmic neighborhood we call home. Further investigations into these newly discovered moons revealed intriguing details about their characteristics. Ranging in size from 1 to 3 kilometers, these moons were identified as regular satellites exhibiting retrograde motion, meaning they orbit Jupiter in a backward direction, opposite to the planet's rotation. This unusual orbital behavior highlights the complex gravitational interactions shaping the Jovian system. Moreover, astronomers determined that the moons display a diverse range of orbital periods. Some take several years to complete a single orbit, while others complete their journeys in just a few months before repeating the cycle. This variation showcases the dynamic and intricate motions of these celestial bodies within Jupiter's vast gravitational sphere. These recent discoveries offer compelling new evidence supporting the pioneering observations made during the Voyager mission of 1979. That historic mission had hinted at the existence of a significant population of moons around Jupiter, and now, with the addition of these newly confirmed satellites, astronomers possess even more robust data to confirm Jupiter's remarkable abundance of natural moons. Such findings underscore the continuous progress in our understanding of the Jovian system and provide valuable insight into the complex dynamics governing the interactions among Jupiter's moons. They fuel our scientific curiosity and deepen our appreciation for the wonders of the universe, reminding us that despite decades of exploration, the cosmos still holds countless mysteries waiting to be uncovered. In the coming months and years, several ambitious space missions by leading space agencies are poised to deepen humanity's understanding of Jupiter and its intriguing moons, ushering in a new era of planetary exploration. Among these, the European Space Agency, ESA, has set its sights on launching a sophisticated spacecraft in April 2023. This mission is designed to study Jupiter and its diverse icy moons with enhanced precision and advanced instrumentation, aiming to unravel the mysteries that surround these distant celestial bodies. The spacecraft will focus on gathering comprehensive data about the planet's atmosphere, magnetosphere, and the unique geophysical features of its moons. Simultaneously, NASA is preparing to launch its highly anticipated Europa Clipper mission, slated for the near future. This mission targets Europa, one of Jupiter's most enigmatic moons, long suspected to conceal a vast, potentially life-supporting ocean beneath its thick icy crust. The Europa Clipper, aimed to perform detailed reconnaissance of the moon's surface and subsurface, analyzing its ice shell, ocean depth and composition, as well as identifying possible locations where life could exist. By probing the ice shell's fractures and geysers, the mission seeks to better understand Europa's habitability and assess its potential to support microbial or even more complex life forms. These forthcoming missions promise to deliver an unprecedented wealth of data and insights, fundamentally enriching our comprehension of the Jovian system and advancing the broader quest to understand the conditions necessary for life beyond Earth. The discoveries made by these spacecraft will not only expand our knowledge of Jupiter and its moons, but will also shed light on planetary formation, geological processes, and the dynamics of icy worlds throughout the solar system. Breakthroughs in studying gas giants like Jupiter and Saturn have, in recent decades, opened up entirely new mysteries and avenues for exploration. These planets are not just distant giant worlds. They are dynamic environments with complex weather systems, powerful magnetic fields, and a rich collection of moons, many of which may be ocean worlds. Understanding these systems can provide key insights into the early history of the solar system and the potential for life in environments vastly different from Earth. Looking to the future, advances in space travel technology such as theoretical developments in light speed or near light speed propulsion may one day allow astronauts to visit the surfaces of these gas giants or their moons directly. While such technology remains speculative and faces significant engineering and physical challenges, it embodies humanity's relentless drive to push boundaries and expand the frontiers of exploration. Visiting Jupiter's and Saturn's moons in person would revolutionize planetary science by enabling direct sampling, detailed surface studies, and on-the-spot investigations of their atmospheres and geophysical characteristics. As we continue this unfolding journey to uncover the secrets of our solar system and beyond, the role of these upcoming missions cannot be overstated. They represent humanity's insatiable curiosity and unwavering commitment to exploring the cosmos, reminding us that despite centuries of study, the universe remains a vast frontier filled with boundless wonders and unanswered questions. We encourage all space enthusiasts and curious minds to stay tuned for updates from these groundbreaking missions. Follow the latest discoveries and share their thoughts and excitement about the future of space exploration. Together, we partake in an unending voyage towards unlocking the secrets of the cosmos, a journey that promises to transform our understanding of the universe and our place within it. The wonders of space exploration truly are boundless, and each new mission brings us closer to grasping the full majesty and mystery of the heavens above. Scientists have recently uncovered extraordinary evidence about a fascinating location within our solar system, one that holds the potential to support life beyond Earth, the icy moon known as Enceladus, which orbits Saturn. Once thought to be a barren, frozen world, Enceladus has now emerged as a prime candidate in the search for extraterrestrial life due to its unique and complex chemical makeup. Data gathered from past missions, especially NASA's Cassini spacecraft, revealed that beneath its thick icy shell lies a hidden ocean of liquid water, enriched with organic molecules essential for life. This subsurface ocean periodically vents plumes of water vapor and ice particles through cracks near the moon's south pole, shooting material high into space. These remarkable geysers suggest that Enceladus has a dynamic interior with the chemical ingredients and environmental conditions that might allow microscopic life to thrive. Scientists are now eagerly preparing for future exploratory missions aimed at sampling these plumes directly to better understand the moon's habitability and the possibility of life in such an extreme environment. Meanwhile, in a very different sphere, a wave of intrigue and excitement has swept through both government circles and the public due to recent disclosures by the US Army. Authorities have declassified a collection of NASA footage that reportedly shows a massive and mysterious unidentified flying object, UFO, sparking intense speculation and discussion worldwide. This footage, which depicts an enormous craft exhibiting flight characteristics beyond current human technology and defying conventional explanation, has challenged established perceptions about aerial phenomena. The revelation has reignited debates over extraterrestrial visitation and the extent of governmental knowledge and transparency regarding such encounters. While scientists and officials urge careful analysis and cautious interpretation, the footage undeniably fuels public curiosity and fascination about what might be lurking in our skies and beyond. Together, these two stories, one grounded in rigorous scientific discovery, the other steeped in mystery and speculation, highlight humanity's relentless curiosity about the universe. The discoveries about Enceladus open up promising new avenues in our quest to find life beyond Earth through methodical, evidence-based exploration. In contrast, the revelation of the UFO footage taps into the imagination and wonder about the unknown, reminding us of the vast mysteries that still elude scientific explanation. Both narratives inspire us to continue exploring and questioning our place in the cosmos, driving humanity's enduring fascination with the stars and the secrets they hold. Stretching over an astonishing 2,000 miles in length, this enigmatic object appeared near the planet Saturn and was captured by some of NASA's most advanced telescopes and satellites. The sheer size and mysterious nature of this colossal UFO have sparked widespread fascination and intense debate among scientists, space enthusiasts, and conspiracy theorists alike. But what exactly lies behind this massive and baffling object? Is it the result of a secret government experiment? A highly classified spacecraft built with cutting-edge technology unknown to the public? Or could it be an actual extraterrestrial spacecraft originating from a civilization far beyond our solar system, silently observing or even visiting our cosmic neighborhood? In this video, we dive deep into the astonishing details recently unveiled by the US Army concerning NASA's footage of this extraordinary 2,000-mile-long UFO near Saturn. The revelations have sent shockwaves through the scientific community and the general public, raising profound questions about the nature of life beyond Earth and the mysteries hidden in the vast reaches of space. Adding to the intrigue is the testimony of former US Army Command Sergeant Major Robert Dean, who has made jaw-dropping claims about alien encounters based on his extensive military experience. Dean has shared compelling accounts from his time in service, suggesting that the government possesses far more knowledge about extraterrestrial visitation than has ever been made public. His insights lend an additional layer of credibility and mystery to the discussion surrounding this colossal object near Saturn. As we explore this remarkable phenomenon, we weigh the evidence, analyze the footage, and consider the wide-ranging implications. Is this the long-awaited proof of alien life? Or are we witnessing something else entirely? A breakthrough in human technology or an optical anomaly? Whatever the answer, the discovery marks a new chapter in humanity's ongoing quest to understand the cosmos and our place within it. Former US Army Command Sergeant Major Robert Dean has emerged as a compelling voice in the ongoing conversation about extraterrestrial encounters, offering rare and captivating insights into humanity's interactions with alien life. Drawing upon his extensive military background, particularly his critical role at NATO headquarters from 1963 to 1967, Dean's statements carry a weight of credibility that few can match in the realm of UFO disclosure. During his tenure, Dean was deeply involved in sensitive projects and briefings that touched on the implications of extraterrestrial presence on Earth. In 1964, he presented a classified assessment paper to NATO officials that analyzed the possible consequences and strategic responses to alien activity. This report, highly confidential at the time, underscored the seriousness with which military leadership regarded the phenomenon, moving it beyond the realm of mere speculation or folklore. At a landmark event commemorating the 50th anniversary of the Roswell incident, one of the most iconic and controversial moments in UFO history, Dean delivered a revealing presentation at Leeds University that stunned attendees and reignited debate worldwide. He disclosed that, during his active service, he had direct knowledge of 4 distinct extraterrestrial groups operating in secret around Earth. However, what is perhaps even more startling is that by the time he retired, this number had expanded dramatically, growing to over 12 separate alien factions. This knowledge was not isolated to just the United States military. Dean suggested that this awareness permeated Allied forces, including the British military, indicating a coordinated and perhaps collaborative understanding of these extraterrestrial presences among international defense communities. Such cooperation hints at the possibility that the reality of alien visitation is much more integrated into global security frameworks than previously imagined. Beyond the dozen or so groups Dean directly referenced, he hinted at a far more complex and bewildering cosmic ecosystem. According to his revelations, there may be over 100 different alien organizations with origins that remain shrouded in mystery. These groups vary widely in their intentions, technologies, and methods of interaction with humanity. Some may be peaceful observers, while others might possess agendas that challenge our concepts of diplomacy and security. If Dean's claims withstand rigorous scrutiny, they have the potential to profoundly reshape humanity's understanding of its place in the universe. The existence of multiple alien organizations, each with distinct histories and purposes, suggests a vast and intricate galactic community that intersects with our world in ways we are only beginning to comprehend. This could revolutionize scientific inquiry, international policy, and even the philosophical and spiritual frameworks through which we view ourselves. In a world where official silence and denial have often been the norm, testimonies like those of Major Robert Dean provide a rare glimpse into the hidden layers of reality that many governments and institutions have long kept under wraps. His disclosures invite us to question what we think we know and to remain open to the possibility that the cosmos is far more populated and far more interactive than ever imagined. Major Dean's revelations significantly deepen our understanding of extraterrestrial involvement on Earth, painting a picture of a far more intricate and nuanced relationship between our planet and distant civilizations than previously acknowledged. According to Dean, some of these extraterrestrial beings bear a striking resemblance to humans. These beings are reported to frequent everyday locations, such as aircraft, restaurants, theaters, and other public venues, blending in so effectively that they often go unnoticed by the general population. This ability to integrate undetected has raised profound concerns about the potential infiltration of these extraterrestrials into key institutions of power. Major Dean specifically mentioned places like the SHAPE, Supreme Headquarters, Allied Powers Europe Headquarters, and the Pentagon as locations where these beings might have established a presence. The implications of such infiltration are staggering, as it suggests that these alien entities could influence military strategies, national security decisions, and perhaps even global politics. The prospect of extraterrestrials entering spaces as sensitive as the White House elicited a range of reactions from military officers. Some responded with amusement, treating the idea as something out of science fiction, while others viewed it with genuine apprehension, recognizing the potentially profound consequences of such infiltration on national sovereignty and security. What sets Major Dean's insights apart is his suggestion that humans and these extraterrestrials may share more than just superficial physical similarities. He proposed a unique perspective that humans might share certain commonalities or even genetic links with some of these alien groups, a notion that challenges traditional views of human origins. This concept opens up fascinating possibilities about ancient interactions between humans and extraterrestrial civilizations, potentially explaining myths, legends, and unexplained advancements in human history. Dean's disclosures urge us to rethink our assumptions about identity, security, and the very nature of human civilization. If extraterrestrials have been quietly coexisting among us, influencing events, and perhaps guiding humanity's development in subtle ways, the implications for science, history, and philosophy are profound. This scenario compels us to expand our search for truth beyond the confines of conventional knowledge, and to embrace a broader, more inclusive vision of the universe. As we continue to explore these revelations, the need for transparent investigation and open dialogue becomes ever more critical. Understanding the true extent of extraterrestrial presence and influence could redefine the future of humanity, shaping policies, technologies, and cultural paradigms in unprecedented ways. Major Dean suggested that humans share striking similarities with certain intelligent alien species, hinting at a deeper, undisclosed reason behind this extraordinary connection. He believed that encounters with extraterrestrials transcend mere planetary interactions, involving evolving beings from diverse star systems and even cosmic realms beyond our conventional understanding. According to Dean, this non-human intelligence possesses multi-dimensional attributes with the remarkable ability to manipulate both time and matter, capabilities that challenge and expand our traditional views of the universe's fundamental nature. Switching gears to the monumental achievements of human space exploration, NASA's Voyager spacecraft serve as a testament to our scientific ingenuity and determination to uncover the mysteries of the cosmos. To power these incredible probes on their long and arduous journeys across billions of kilometers, NASA employed nuclear energy through radioisotope thermoelectric generators, RT. These RTGs function by converting the heat produced from the natural decay of plutonium-238 into continuous electrical power, ensuring that the Voyager spacecraft remain operational and transmit vital data back to Earth regardless of their immense distance from the Sun. Each Voyager probe was outfitted with approximately 722 kilograms of scientific instruments, radio systems, and power sources, complex equipment requiring substantial and reliable energy to function effectively. Beyond powering these instruments, the spacecraft needed precise control to maintain their trajectory and prevent aimless drifting through the void of space, highlighting the impressive engineering achievements behind the Voyager missions. Together, the profound mysteries of alien intelligence and the technological marvels of human space exploration illustrate the boundless frontiers that continue to push our understanding of existence, urging us onward in the quest for knowledge that transcends the stars. NASA meticulously planned the Voyager missions, carefully calculating their trajectories by leveraging the powerful gravitational assists provided by Jupiter and Saturn. These gravity assists acted like cosmic slingshots, boosting the spacecraft's speed and enabling them to approach the outer planets with remarkable precision. Every detail was thoughtfully considered, leaving no stone unturned in preparation for this unprecedented journey into the far reaches of our solar system. Exploring the outer planets during the 1970s posed significant challenges. Spaceflight technology was still in its infancy, and navigation systems lacked the sophistication we have today. Despite these obstacles, the Voyager mission pressed forward with unwavering determination. Initially, NASA had envisioned sending a single probe on what was called the Grand Tour, a unique opportunity to take advantage of a rare alignment of the 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. However, budgetary constraints forced a reconsideration of this plan. To maximize scientific returns while controlling costs, NASA decided to launch 2 identical spacecraft, Voyager 1 and Voyager 2, each on separate trajectories designed to explore different parts of the outer solar system. Voyager 1's mission focused on close encounters with Jupiter and Saturn, while Voyager 2 was tasked with venturing farther to study Uranus and Neptune. Voyager 1's arrival at Jupiter marked a breakthrough moment in planetary exploration. Among its most remarkable discoveries was the moon Io, which was revealed to be geologically active, a phenomenon previously believed to be exclusive to Earth. Despite being only about 1/3 the size of Earth, Io displayed volcanic activity that was astonishingly intense, generating twice as much energy as Earth and making it the most geologically dynamic body in our entire solar system. This revelation revolutionized our understanding of the diversity and complexity of celestial bodies, challenging long-held assumptions about planetary geology. Io's surface was dramatically shaped by intense tectonic activity and frequent volcanic eruptions. These dynamic geological processes were driven primarily by powerful gravitational interactions with Jupiter and the other Galilean moons. The immense tidal forces generated by Jupiter's gravity constantly flexed Io's interior, generating heat and fueling its extraordinary volcanic activity. This unexpected discovery fundamentally changed scientists' understanding of the diversity and complexity of celestial bodies within our solar system. It challenged prior assumptions that geological activity was limited to Earth and expanded our knowledge of planetary geology in profound ways. Voyager 1's mission to Jupiter did not stop with Io. The spacecraft unveiled a wealth of remarkable and unexpected findings about the gas giant itself. One of the most striking revelations was that Jupiter's magnetosphere, the magnetic field surrounding the planet, was far larger and more powerful than previously estimated. It extended billions of kilometers into space, reaching as far as Saturn's orbit, effectively dominating a vast region of the solar system. In addition to magnetospheric discoveries, Voyager 1's instruments detected a complex mixture of elements in Jupiter's atmosphere. These included hydrogen and helium, the primary components, along with trace amounts of water vapor, methane, ammonia, and various rocky materials. This diverse atmospheric composition provided valuable insights into the formation and evolution of the largest planet in our solar system. Voyager 1 also captured the first close-up images of a narrow, dark ring encircling Jupiter. Scientists believe this ring likely originated from debris created by an ancient moon that had broken apart. This discovery added a new dimension to our understanding of Jupiter's ring system, which is far more subtle and elusive compared to the spectacular rings of. Further observations during the mission revealed surprising features about Ganymede, Jupiter's largest moon and the largest moon in the entire solar system. Voyager 1 detected that Ganymede possesses a thin atmosphere, a fact previously unknown before the mission. This tenuous atmosphere, composed mainly of oxygen, provided new clues about the moon's surface and potential geological or exospheric processes at play. These unexpected discoveries profoundly deepened our understanding of Jupiter's magnetosphere, its complex atmospheric composition, and the unique characteristics of its moons. Together, these findings significantly expanded our knowledge of this colossal gas giant and the intricate environment that surrounds it. Following its groundbreaking observations at Jupiter, the Voyager missions pressed onward into the outer solar system, with Voyager 1 leading the charge toward Saturn. The spacecraft's encounter with Saturn proved to be equally remarkable, unveiling astonishing insights into the planet and its moons. As Voyager 1 approached Titan, Saturn's largest moon, scientists were taken aback by a surprising revelation. Titan's solid core was found to have a smaller diameter than Ganymede, the largest moon of Jupiter and indeed the largest in the entire solar system. This discovery was unexpected and challenged earlier assumptions about the sizes and internal compositions of these celestial bodies. This revelation offered a fresh perspective on the remarkable diversity and complexity of moons in our solar system. It provided invaluable data that continues to inform and guide scientific inquiry into the origins, evolution, and dynamic processes of planetary satellites. The Voyager missions significantly expanded our knowledge and understanding of Saturn and its magnificent moons in ways never before achieved. Through their close flybys and sophisticated onboard instruments, Voyager 1 and Voyager 2 provided invaluable data that has fueled scientific research and discoveries for decades. These missions revealed intricate details about Saturn's stunning ring system, its atmospheric dynamics, and the diverse geological features of its many moons, each unique in its own right. From the towering ice cliffs on Enceladus to the dense atmosphere of Titan, Voyager's observations opened new windows into the complexities of the outer solar system. Despite the immense challenges posed by the harsh conditions of deep space, extreme cold, intense radiation, and the vast distances separating Earth from the outer planets, these pioneering spacecraft have continued to operate far beyond their original mission timelines. Their resilience and continued functionality stand as a testament to the ingenuity and foresight of the engineers and scientists who designed them. Even after more than 4 decades, the enduring connection between Voyager 1 and Voyager 2 and NASA's Deep Space Network remains a remarkable technological achievement. This global system of large radio antennas allows the spacecraft to transmit valuable scientific data back to Earth and receive commands from mission control, despite being billions of miles away. While Voyager 1 and Voyager 2 may have long since passed the immediate vicinity of the outer planets, their missions are far from complete. Both spacecraft have now entered interstellar space, the vast region beyond the influence of our Sun's solar wind. In this largely unexplored frontier, the Voyagers continue to provide unique insights into the conditions of the interstellar medium, including measurements of cosmic rays, magnetic fields, and interstellar particles, offering humanity an unprecedented glimpse of the environment that exists between the stars. These continued discoveries not only enrich our understanding of the universe around us, but also inspire future generations to push the boundaries of exploration further than ever before. The Voyager missions remain among the most enduring and successful endeavors in the history of space exploration, reminding us that even the most ambitious human ventures can yield rewards for decades and far beyond their original scope. The Voyager missions have fundamentally rewritten the textbooks of planetary science, revolutionizing our understanding of the outer planets and their complex systems. Their groundbreaking discoveries have not only provided invaluable insights into worlds previously unseen, but have also ignited the imaginations of countless scientists, researchers, and space enthusiasts around the globe. These missions stand as shining examples of human curiosity and ingenuity, embodying the relentless pursuit of knowledge about our place in the vast cosmos. As we reflect on the extraordinary achievements of Voyager 1 and Voyager 2, we are reminded of the profound impact these spacecraft have had on our collective understanding of the universe. They have revealed new mysteries and expanded the horizons of what we thought possible in space exploration. The wealth of data returned by the Voyagers continues to inform and inspire scientific research, pushing the boundaries of planetary science and astrophysics. Moreover, the legacy of the Voyager missions serves as a powerful testament to what humanity can accomplish when united by a shared vision to explore the unknown. Their epic journey into the far reaches of our solar system and now beyond into interstellar space symbolizes the enduring spirit of exploration that has driven humankind throughout history. It is a story of courage, determination, and the unquenchable thirst for discovery. The Voyager's Odyssey reminds us that space exploration is not merely about machines traveling through the cosmos, but about the collective dreams, hopes, and aspirations of all people who dare to look up at the stars and wonder. It inspires us to continue reaching higher, pushing further, and dreaming bigger. Ultimately, the story of Voyager 1 and Voyager 2 is a testament to the limitless curiosity that defines us as a species. an unending quest to understand the universe and our place within it. Their ongoing mission stands as a beacon of human achievement, encouraging future generations to carry forward this spirit of discovery, ensuring that our journey to the stars is far from over. The culmination of India's tireless efforts in lunar exploration is manifesting in the remarkable Chandrayaan-3 mission, a voyage of discovery that has ushered in an exciting new chapter in humanity's quest to unravel the secrets of the moon. This mission, spearheaded by the Indian Space Research Organization, ISRO, represents a monumental leap forward, not only for India, but for the entire global space community, igniting a fervor of anticipation and curiosity that resonates far beyond the Earth's atmosphere. Chandrayaan-3 stands as a testament to the remarkable progress made by ISRO, building upon the legacy of its predecessors, Chandrayaan 2 and 3. While these missions laid the groundwork by mapping the lunar surface and attempting a soft landing, Chandrayaan-3 carries the hopes of a successful touchdown on the moon's surface, a goal that embodies India's unwavering determination and scientific ingenuity. Equipped with sophisticated instruments and cutting-edge technology, Chandrayaan-2 is designed to explore the moon's south pole, a region rich in mysteries and potential resources, including water ice, which holds the key to sustaining future human settlements and long-term lunar missions. The mission's success will not only deepen our understanding of the moon's geology and composition, but also pave the way for international collaborations in space exploration. As Chandrayaan-3 journeys through the void between Earth and Moon, millions watch with bated breath, inspired by a vision that transcends borders and cultures. This mission symbolizes the collective human spirit, a relentless pursuit to push boundaries, to seek knowledge, and to stand united in the face of the cosmos's vast unknown. In the grand tapestry of space exploration, Chandrayaan-3 is a shining thread, weaving together past triumphs and future possibilities. It heralds an era where emerging space powers contribute invaluable knowledge, inspiring generations to dream bigger and reach farther. As the lander prepares to touch the lunar surface, we are reminded that exploration is not just about discovery, it is about hope, resilience, and the shared destiny of all humankind. Chandrayaan-3 invites us to look upward with wonder, to celebrate human achievement, and to embark on the next great adventure that awaits us on the moon and beyond. Boundaries dissolve as the saga of Chandrayaan-3 unfolds, a remarkable testament to human ingenuity, technological prowess, and the unquenchable thirst for knowledge that propels our species to traverse the uncharted reaches of space. This mission encapsulates the very spirit of exploration, inviting us all to witness the unfolding mysteries of the moon in unprecedented detail. The captivating sequence of images unveiled by Chandrayaan-3 speaks volumes about the journey from curiosity to discovery. Each frame, carefully captured by the sophisticated instruments aboard the spacecraft, reveals the lunar surface with increasing clarity and nuance. The moon's ancient craters, once mere shadows on a distant orb, now emerge vividly, etched with intricate details shaped over billions of years. As these breathtaking snapshots cascade across screens worldwide, they do more than just showcase geological features, they ignite the collective imagination of humanity. They remind us of our enduring desire to push beyond familiar horizons and to decipher the cosmic story written across the moon's surface. Every crater, ridge, and shadow tells a tale of cosmic collisions, volcanic activity, and the subtle dance of celestial bodies through time. The images from Chandrayaan-3 are not just scientific data, They are symbols of a grand human endeavor, a clarion call to future explorers and dreamers. They underscore the profound significance of this mission, not only as a scientific achievement, but also as a cultural milestone that brings the world closer through shared wonder. Through Chandrayaan III, India has firmly etched its place in the annals of space exploration, demonstrating that the quest to understand our celestial neighbor transcends national boundaries. It is a story of collaboration, perseverance, and visionary thinking that unites humanity in the pursuit of knowledge. As the mission progresses, each new discovery fuels our aspirations, pushing us closer to answering timeless questions about the moon's origins, its resources, and its role in the broader cosmic landscape. Chandrayaan III, with its trailblazing vision, beckons us forward toward a future where the moon is not just a distant object in the night sky, but a stepping stone for deeper exploration of the universe. In this journey, we find inspiration to dream boldly, explore fearlessly, and embrace the infinite possibilities that await us beyond our earthly home. Chandrayaan III's groundbreaking achievement in executing a controlled soft landing on the moon's surface is poised to etch India's name in the annals of history as a pioneering force in lunar exploration. This historic milestone resonates deeply with the essence of human ambition, perseverance, and the relentless pursuit of innovation that define our species. By masterfully orchestrating this controlled soft landing, the Indian Space Research Organization ISRO has firmly positioned itself at the forefront of space exploration, cementing its status as a trailblazer among nations engaged in interplanetary endeavors. This success marks a transformative moment not only for India, but for the global scientific community, showcasing the power of vision, dedication, and cutting-edge technology. Stepping back in time, the Chandrayaan project embarked on its odyssey in 2008, marking a seminal moment in India's space journey. This ambitious mission heralded a new era of lunar research and discovery, setting the stage for a series of groundbreaking revelations. The first spacecraft in the Chandrayaan series ignited hopes and aspirations as it delivered India's maiden foray to the moon, mapping its surface and uncovering critical data that reshaped our understanding of Earth's celestial companion. Chandrayaan I's success was followed by Chandrayaan II, which further expanded the scope of exploration by deploying a lunar orbiter and attempting a soft landing, though the landing module faced challenges. However, these early missions laid the foundation for the remarkable achievements of Chandrayaan III, embodying the lessons learned and technological advances accrued over more than a decade, represents the culmination of relentless scientific endeavor. Its successful soft landing is a testament to ISRO's commitment to pushing boundaries and embracing the complexities of space travel. This achievement echoes the pioneering spirit of past explorers who dared to venture beyond the known, driven by curiosity and an insatiable quest for knowledge. The mission not only advances lunar science, but also inspires a generation of scientists, engineers, and dreamers. It serves as a beacon of possibility, proving that with determination and ingenuity, even the most daunting challenges can be overcome. As Chandrayaan III continues its journey, it carries with it the hopes of a nation and the aspirations of humanity to unlock the moon's secrets. Secrets that hold keys to understanding planetary evolution, potential resources, and the broader mysteries of the cosmos. In this grand narrative of exploration, India's pioneering lunar mission stands as a shining chapter, a bold testament to human perseverance and the unyielding spirit of discovery that propels us to the stars. Chandrayaan-I marked an unprecedented leap forward in lunar exploration with its groundbreaking discovery of water molecules on the Moon's surface. This watershed moment not only revolutionized our understanding of the Moon, but also fundamentally altered the trajectory of space exploration. Prior to this discovery, the Moon was largely considered a barren, desolate world, devoid of the key elements that might support life or long-term human presence. However, the confirmation of water, even in trace amounts, unlocked new possibilities that extended far beyond the scientific community. It raised profound questions about the Moon's formation, its geological evolution, and the potential for sustaining future human colonies. This discovery sparked a renaissance in lunar science, with nations around the world redoubling their efforts to study and explore the Moon. It underscored the Moon's potential not only as a scientific laboratory, but also as a strategic waypoint for humanity's deeper ventures into the solar system. Water ice, particularly in permanently shadowed craters near the lunar poles, could serve as a critical resource for life support, fuel production, and other essential needs for sustained space missions. Thus, Chandrayaan-I's legacy transcended the realm of discovery to become a cornerstone of future space exploration planning. Building upon these revelations, Chandrayaan-2 expanded the scope of lunar investigation, deploying an orbiter, a lander, and a rover designed to perform a wide array of scientific experiments. Despite the tragic loss of the Vikram lander during its attempted soft landing, the mission yielded valuable orbital data that enhanced our understanding of the Moon's surface composition, mineralogy, and the intricate dynamics of its tenuous exosphere. This mission reaffirmed India's resolve and technical capability in the fiercely competitive arena of space exploration. Now Chandrayaan-3 emerges as a bold continuation and evolution of India's lunar aspirations. It embodies the lessons learned, the technological advancements achieved, and the unwavering commitment to pushing the frontiers of knowledge. This mission's ambitious objective, to achieve a successful controlled soft landing and deploy a rover on the lunar surface, represents a crucial step forward not just for India, but for humanity's collective quest to comprehend the cosmos. The scientific goals of Chandrayaan-3 are multifaceted and profoundly significant. It aims to map the lunar surface in unprecedented detail, focusing particularly on the polar regions, where water ice is believed to be concentrated. Understanding the distribution, abundance, and state of lunar water is vital for future in situ resource utilization, ISRU, which will be essential for establishing sustainable human presence on the Moon and beyond. Furthermore, Chandrayaan-3 will investigate the Moon's geology, seismic activity, and the interaction of solar radiation with the lunar environment. Areas that remain shrouded in mystery despite decades of study. Technologically, Chandrayaan-3 represents a marvel of engineering innovation. The mission integrates state-of-the-art navigation, autonomous landing systems, and advanced scientific instrumentation designed to operate in the Moon's harsh and unforgiving environment. Its success will demonstrate not only India's growing prowess in space technology, but also its ability to collaborate globally, sharing data, expertise, and insights with international space agencies to foster a cooperative approach to exploring our celestial neighbor. On a broader scale, Chandrayaan-3 symbolizes the spirit of human curiosity and perseverance that drives our species to explore the unknown. It is a testament to the power of innovation, the importance of international cooperation, and the unyielding desire to push beyond the limits of our current knowledge. As the mission unfolds, it promises to yield discoveries that could redefine our understanding of the Moon and its role in the solar system, offering clues about the origins of Earth and the early history of our cosmic neighborhood. Moreover, Chandrayaan-2's success would inspire a new generation of scientists, engineers and dreamers, not only in India, but across the globe, fueling ambitions that transcend national borders and unite humanity in the shared pursuit of knowledge and exploration. It stands as a beacon of hope and progress, illuminating the path toward a future where humans might one day live and thrive beyond Earth. In conclusion, Chandrayaan-3 is far more than a technological mission. It is a narrative of discovery, resilience, and aspiration. It continues the story that began with the discovery of lunar water, unfolding new chapters that promise to deepen our connection with the Moon and, by extension, the universe itself. As we eagerly anticipate the data and images this mission will deliver, we stand on the threshold of a new era in space exploration, one defined by courage, collaboration, and the boundless potential of human ingenuity. The Chandrayaan-3 mission embarks on a profoundly ambitious journey to unravel the intricate tapestry of the Moon's ancient past. With scientific rigor and technological prowess, this mission is designed to meticulously dissect the layers of lunar history, aiming to tease apart the complex threads of the Moon's evolution and formation. By doing so, it aspires to offer unprecedented insights into the early dynamics of our solar system, helping humanity to reconstruct the cosmic events that led to the birth of planetary bodies and the sculpting of their geological identities. At its core, Chandrayaan-3 is not merely an exploration of barren rock and dust. It represents a voyage into the very origins of our celestial companion, a quest to comprehend the forces that have shaped its surface over billions of years. By studying impact craters, volcanic formations, and the chemical composition of lunar soils and rocks, scientists hope to uncover clues about the Moon's internal structure and thermal history. These insights will, in turn, enhance our understanding of planetary formation, the history of cosmic bombardments, and the subtle interplay between celestial bodies within our solar system. However, the scope of Chandrayaan-3 extends beyond pure geology into the tantalizing realm of astrobiology. One of the mission's most groundbreaking ambitions lies in assessing the Moon's capacity to support life, a pursuit that pushes the boundaries of scientific inquiry and challenges the traditional view of the lunar environment as utterly inhospitable. Although the Moon's surface is exposed to harsh radiation, extreme temperature fluctuations, and a near vacuum, recent discoveries, such as the presence of water ice in permanently shadowed craters, have opened new windows of possibility. Chandrayaan-3 seeks to delve deeper beneath the Moon's surface, probing for microscopic life forms or biosignatures that may have survived or been preserved within the subsurface environment. The mission's sophisticated instruments are designed to analyze lunar rocks and soil samples with unprecedented precision, searching for organic compounds, isotopic anomalies, or mineralogical evidence that could point toward past or present life. Such a discovery would not only revolutionize our understanding of life's resilience, but also radically alter our conception of where life can exist in the universe. A key aspect of this mission involves the detailed examination of lunar craters, which serve as natural archives of cosmic history. These impact sites have, over eons, collected and preserved materials from various regions of the Moon and even from other celestial bodies. By studying these craters, Chandrayaan-E scientists aim to reconstruct the Moon's bombardment history, understand the distribution of water and volatile elements, and assess how these factors might influence the potential habitability of certain lunar regions. Moreover, Chandrayaan-3's comprehensive survey of the lunar surface encompasses the analysis of moon rocks brought back by previous missions, as well as fresh samples studied in situ by onboard instruments. This multifaceted approach aims to map out the Moon's geochemical and mineralogical diversity, which is essential for identifying regions of interest for future human habitation and resource utilization. Understanding the distribution of essential elements like hydrogen, oxygen, and metals could pave the way for establishing sustainable lunar bases and advancing humanity's long-term presence beyond Earth. By venturing into these uncharted territories, Chandrayaan-3 does more than expand our scientific knowledge. It inspires a profound philosophical and existential reflection on humanity's place in the cosmos. The mission embodies the spirit of exploration, innovation, and international collaboration, reflecting a global yearning to push the boundaries of the known and embrace the mysteries that lie beyond our home planet. In conclusion, the Chandrayaan-3 mission stands as a beacon of human perseverance and curiosity, a monumental leap forward in our ongoing quest to comprehend the Moon and its secrets. Through its groundbreaking objectives, ranging from decoding the Moon's ancient geological past to probing its potential for life, it promises to transform our understanding of the lunar environment and, by extension, the broader universe. As this odyssey unfolds, it invites us all to imagine a future where the Moon is not just a distant orb in the night sky, but a dynamic world teeming with secrets, waiting to be unveiled by the relentless human spirit of discovery. Through meticulous examinations and advanced scientific investigations, Chandrayaan-3 endeavors to answer some of the most profound and age-old questions about the Moon's potential to support life. By probing beneath its surface and analyzing its geological and environmental characteristics, this mission seeks to fundamentally redefine our understanding of habitability beyond Earth. It challenges long-standing assumptions about the harshness of the lunar environment and explores whether the Moon could in fact harbor the essential conditions necessary for sustaining human life, or even simpler forms of biological existence. The audacious dream of establishing permanent human colonies on the Moon has long tantalized humanity's collective imagination. For decades, the notion of lunar settlements has inspired countless scientists, engineers, and visionaries who see the Moon as both a stepping stone and a sanctuary for the future of human civilization. With Chandrayaan-3, this once distant and speculative vision edges closer to tangible reality. Through a comprehensive suite of scientific instruments and sensors, the mission conducts intricate assessments of lunar temperatures, radiation levels, regolith composition, and surface stability. These data points are critical in identifying regions that offer the most favorable environmental conditions for human habitation. The ISRO's calculated pursuit of suitable locations for human settlement is a crucial step in ensuring that future astronauts can live and work safely on the lunar surface. Factors such as prolonged sunlight exposure, availability of water ice, and minimal exposure to harmful cosmic radiation are carefully evaluated. By pinpointing optimal sites that combine these favorable conditions and ultimately permanent lunar bases, permanent lunar bases. These colonies could serve as hubs for scientific research, resource extraction, and even interplanetary travel, transforming the Moon from a remote celestial body into a vibrant outpost of human activity. Furthermore, the mission's findings on the Moon's environmental dynamics will inform the development of advanced technologies needed to sustain life in this challenging extraterrestrial setting. Innovations in habitat construction, life support systems, and resource recycling will benefit from the detailed environmental data gathered by Chandrayaan. This endeavor not only represents a triumph of engineering and scientific ingenuity, but also embodies humanity's relentless spirit of exploration and survival. In essence, Chandrayaan-3 stands as a milestone in humanity's quest to extend its reach beyond Earth's cradle. By illuminating the possibilities of lunar habitability, it fuels hope that one day humans will thrive not just on our home planet, but across the wider cosmos. As we inch closer to making the dream of lunar colonization a reality, Chandrayaan-3 serves as both a beacon and a bridge, connecting the dreams of today with the achievements of tomorrow. This mission exemplifies humanity's unwavering determination to extend our presence beyond Earth, echoing the tenacity and spirit of discovery that has driven explorers and pioneers throughout history. Chandrayaan-3 is not merely a technological endeavor, it embodies the relentless pursuit of knowledge and the innate curiosity that propels us to push past known frontiers and embrace the unknown. At the heart of Chandrayaan-3's scientific pursuits lies one of its most remarkable instruments, the radio anatomy of moon-bound, hypersensitive ionosphere and atmosphere, or RAMBAR payload. This sophisticated and highly sensitive instrument is engineered to unveil the subtle and complex intricacies of the Moon's tenuous atmosphere. Though the lunar atmosphere is incredibly thin compared to Earth's, understanding its composition, density, and behavior is crucial for grasping the environmental conditions that prevail on our closest celestial neighbor. RAMBA's primary mission is to measure the density of charged particles and monitor their temporal fluctuations with unprecedented precision. These charged particles interact with solar radiation and cosmic phenomena, creating dynamic patterns within the Moon's ionosphere. Patterns that remain largely mysterious to scientists. By studying these phenomena in depth, RAMBA promises to revolutionize our understanding of the Moon's atmospheric dynamic. The insights gleaned could shed light on processes that have implications not only for lunar science, but also for broader planetary atmospheres and space weather interactions. The revelations from RAMBA will contribute to a more comprehensive comprehension of this enigmatic celestial body, enriching our understanding of how the Moon's environment responds to solar activity and cosmic forces. Such knowledge is vital for future manned missions, ensuring astronauts are better prepared for the challenges posed by the lunar environment. Complementing these scientific breakthroughs, the recent release of mesmerizing images captured by Chandrayaan-3 as it embarked on its lunar journey is nothing short of awe-inspiring. These stunning visual documentations of the mission's progress serve as a poignant reminder of humanity's shared aspirations and collective ingenuity. Each image captures a moment in a venture that represents not just a technological feat, but a symbol of hope, ambition, and the unyielding human spirit. Together, the scientific and visual achievements of Chandrayaan-3 stand as a testament to the power of collaboration, innovation, and perseverance. They remind us that while the Moon may be a distant world, it is one that we continue to approach with reverence, curiosity, and a boundless desire to explore. Through missions like Chandrayaan-3, humanity writes a new chapter in the ongoing saga of cosmic exploration. One where every discovery brings us closer to understanding our place in the universe. The indomitable spirit of humanity, coupled with its ability to transcend boundaries in the relentless pursuit of knowledge, shines brilliantly through the Chandrayaan missions. As the spacecraft entered lunar orbit, following a successful Earth orbit insertion, the world bore witness to a remarkable achievement in interplanetary exploration. This milestone not only underscored India's growing prominence on the global space stage, but also signaled a new era in the democratization of space science, where emerging nations stake their claim among spacefaring giants. The Chandrayaan narrative, though marked by numerous accomplishments, has not been without its share of challenges and setbacks. The Chandrayaan-2 mission in particular brought a bittersweet moment for the Indian Space Research Organisation, ISRO, and space enthusiasts worldwide. The loss of the Vikram lander during its critical descent to the lunar surface was a stark reminder of the immense difficulties and unpredictability inherent in space exploration. Yet, rather than deterring the mission or dimming the aspirations of Indian scientists and engineers, this setback galvanized ISRO's resolve. It became a catalyst for introspection, innovation, and renewed determination to learn from past experiences, paving the way for more refined strategies and heightened success in future missions. However, the journey of Chandrayaan has not been free from critique. A discernible voice of skepticism has emerged, questioning the financial investment allocated to space programs in the face of pressing socio-economic challenges on Earth. Critics argue that the vast resources funneled into space exploration might be better spent addressing immediate issues such as poverty, healthcare, and education. This debate, though valid in its concerns, overlooks the multifaceted benefits that space science brings, not only in advancing technology and scientific understanding, but also in inspiring generations, fostering international cooperation and driving economic growth through innovation. In response, proponents highlight that the Chandrayaan missions serve as a beacon of national pride and a testament to India's technological prowess. The spin-offs from space technology often translate into tangible improvements in communication, disaster management, environmental monitoring, and many other sectors critical to societal development. Moreover, the scientific knowledge gleaned from lunar exploration feeds into our broader understanding of planetary science, the origins of the solar system, and even the conditions necessary for life. Ultimately, the story of Chandrayaan is more than a chronicle of technological feats. It is a narrative of resilience, vision, and the unyielding quest to push humanity's horizons. It invites us to appreciate that while the road to the stars may be fraught with obstacles, each step forward enriches the collective human experience and sets the stage for future generations to dream even bigger. The debate surrounding space exploration often intensifies when weighed against competing societal needs. Critics argue that the substantial resources dedicated to missions like Chandrayaan-3 could instead be redirected to address more immediate concerns, such as improving education, enhancing transportation infrastructure, or alleviating poverty. These voices emphasize the importance of prioritizing urgent terrestrial challenges, suggesting that the allocation of funds towards space projects might be seen as a luxury in the face of pressing social demands. Despite these reservations, the broader public sentiment largely embraces space exploration as a powerful symbol of human progress, intellectual curiosity, and the relentless pursuit of knowledge. For many, ventures into the cosmos are not mere scientific endeavors, they represent humanity's enduring spirit to push boundaries, discover the unknown, and inspire future generations. However, the intersection of space exploration and public discourse is not without its complexities and controversies. A notable incident involving a university lecturer who faced disciplinary action for publicly expressing skepticism about the success of Chandrayaan-3 brought these tensions into sharp relief. This episode highlighted the intricate balance between freedom of expression and the pursuit of national objectives in the context of high-profile scientific missions. It raised critical questions about how dissenting voices are managed, especially when they challenge projects deemed vital to national pride, technological advancement, and international standing. This delicate interplay between critique and support reflects the broader challenges faced by societies as they navigate the dual imperatives of fostering open dialogue and rallying collective effort behind endeavors with far-reaching implications for society, economics, and technological innovation. It underscores the necessity of cultivating a space for informed debate while also recognizing the strategic importance of scientific achievements that elevate a nation's stature on the global stage. As Chandrayaan-3 progresses in its mission, its significance transcends far beyond the mere visual spectacle of its lunar approach. This mission marks a groundbreaking departure from previous lunar explorations, boldly venturing into uncharted territory by targeting a landing near the Moon's south pole, a region characterized by extreme temperatures, prolonged periods of darkness, and unique geological features largely unexplored until now. This audacious leap into the unknown reflects not only a technical feat, but also a profound expansion of humanity's quest to understand the cosmos. The south pole of the Moon is a realm of stark contrasts, where some crater floors remain in perpetual shadow, potentially harboring reservoirs of water ice, an invaluable resource for future lunar settlements and a key to unlocking the Moon's secrets. By focusing its efforts on this enigmatic region, Chandrayaan-3 challenges conventional wisdom and reshapes our collective perception of space exploration, moving the endeavor from broad reconnaissance to targeted investigation of high scientific value. Amidst the captivating imagery and ambitious goals of the mission lies an even more profound question that has intrigued scientists and philosophers alike for centuries. Does life, in any form, exist beyond Earth? The tantalizing possibility of water on the lunar surface, initially hinted at by Chandrayaan-I and later reinforced by subsequent missions, kindles hope that the Moon, despite its harsh and inhospitable environment, might host the conditions necessary to sustain life, or at least preserve its chemical precursors. Chandrayaan-3's meticulous scientific investigations focus intently on probing this possibility. Equipped with advanced instruments, the mission undertakes a comprehensive analysis of the lunar surface's mineral composition, temperature variations, and the presence of volatiles such as water ice. By studying craters, rocks, and the subtle traces of the Moon's geological history, the mission aspires to piece together the intricate puzzle of the Moon's evolution and its potential to harbor microscopic life forms or organic compounds. Beyond the scientific ambitions, Chandrayaan-3 also symbolizes humanity's enduring aspiration to extend our footprint beyond Earth. Its focus on the South Pole is crucial for identifying potential sites for future human habitation, locations where access to water ice and manageable temperatures might one day sustain lunar colonies. This bold endeavor exemplifies the unyielding determination of humankind to explore, innovate, and survive in environments once thought utterly inhospitable. Moreover, embedded within Chandrayaan-3's scientific pursuits is the radio anatomy of moon-bound hypersensitive ionosphere and atmosphere payload. This sophisticated instrument is designed to shed new light on the moon's tenuous atmosphere by measuring the density and temporal fluctuations of charged particles. Insights from Rambra promise to revolutionize our understanding of the moon's atmospheric dynamics, adding yet another layer to our knowledge of this enigmatic celestial neighbor. As Chandrayaan-3 spacecraft gracefully enters lunar orbit, the world watches in awe, witnessing a landmark achievement that marks India's growing prominence in the global space arena. The mission's success not only cements India's status as a trailblazer in space exploration, but also ignites a renewed sense of wonder and possibility for all humanity. Yet, the Chandrayaan saga is not without its challenges. The bitter disappointment of Chandrayaan-2's Vikram lander loss during descent was a stark reminder of the unpredictability and peril inherent in space exploration. However, rather than dampening spirits, this setback galvanized ISRO's resolve, inspiring the team to learn, innovate, and chart an even more ambitious course toward future success. Despite the overwhelming excitement and pride surrounding Chandrayaan-3, the mission has not escaped scrutiny. Critics question the allocation of significant resources to space exploration amid urgent societal needs like education, healthcare, and infrastructure. This ongoing debate reflects the broader tension between investing in visionary scientific endeavors and addressing immediate human concerns. A balance that each nation must navigate thoughtfully. In this context, Chandrayaan-3 stands as a beacon of human ingenuity, perseverance, and the insatiable curiosity that drives us to reach for the stars. It embodies the spirit of exploration that has propelled humanity forward throughout history and offers a powerful reminder that the quest for knowledge often requires bold leaps into the unknown. As Chandrayaan-3 unfolds its scientific journey, it invites us to imagine a future where humanity's presence extends beyond Earth's cradle, where lunar colonies may become realities, and where the mysteries of our cosmic neighborhood continue to inspire and challenge us. The mission's triumphs and trials alike enrich our shared story of discovery, innovation, and the enduring human spirit. The investigations undertaken by Chandrayaan-3 carry the profound potential to fundamentally rewrite the narrative of habitability beyond Earth. They invite humanity to expand its imagination, to envision new possibilities for the existence of life in the vast expanse of the cosmos. By probing the moon's mysteries with unprecedented precision, Chandrayaan-3 challenges long-held assumptions about where life might thrive, encouraging us to rethink the potential for habitability not just on our celestial neighbor, but across the universe. The saga of Chandrayaan's evolution is ultimately a story of resilience, perseverance, and visionary determination. Each phase of the mission builds upon the achievements and lessons of its predecessors, marching steadily toward an exciting horizon filled with promise and new prospects for humanity's future in space. As Chandrayaan-3 continues to blaze new trails, it sets the stage for forthcoming endeavors. Chandrayaan-4, Chandrayaan-5, and beyond. Missions destined to deepen our understanding of the moon's enigmatic terrains and the untapped potential they hold for humankind's exploration and perhaps even settlement. Chandrayaan-3 is far more than a scientific mission. It is a resounding testament to human innovation, grit, and the insatiable quest for knowledge. Its journey reflects the collective aspirations of a species driven by curiosity and a yearning to transcend earthly boundaries. As the story of this mission unfolds, it invites us all to ponder our place within the cosmos, our role in the grand cosmic narrative, and to dream boldly of the boundless possibilities that lie beyond the familiar confines of Earth. In this grand voyage of exploration, Chandrayaan III shines brightly as a beacon of hope, a symbol of progress and a harbinger of transformative potential. It embodies the spirit of discovery that propels humanity forward and signals a future where our reach extends far beyond our home planet. With every new revelation, Chandrayaan III brings us closer to realizing the dreams of interplanetary exploration and the hopeful prospect of a multi-planetary civilization. In closing, Chandrayaan III's mission stands as a powerful embodiment of human endeavor, a tribute to our creativity, perseverance, and unyielding curiosity. It calls upon us to embrace the unknown with open minds and hearts, to continue pushing the boundaries of what is possible, and to prepare for a future where humanity's destiny is intricately woven into the fabric of the cosmos. Chandrayaan III stands not only as a monumental achievement in the annals of space exploration, but also as a profound symbol of humanity's enduring aspiration, a celebration of scientific progress and an inspiring harbinger of a future where the moon's deepest mysteries unfold before our very eyes. Each discovery made by this remarkable mission, every breathtaking image captured, and each groundbreaking revelation reaffirms our collective dedication to the relentless pursuit of knowledge. It is through this unwavering commitment that we continue the awe-inspiring journey that propels humanity ever onward toward the stars. As Chandrayaan III navigates its lunar odyssey, it carries with it the hopes and dreams of millions across the globe, reminding us that we are united in our quest to push beyond the limits of our understanding. The mission is a testament to the power of human ingenuity, collaboration, and the indomitable spirit that drives us to explore the unknown realms of our solar system. With every milestone achieved, Chandrayaan III ignites a spark of inspiration that transcends borders and generations, fueling the collective imagination and sparking new possibilities for scientific discovery. Looking ahead, we stand on the precipice of a future brimming with limitless potential, a future in which humanity's reach extends far beyond the confines of our home planet. The moon, once merely a distant celestial object admired from afar, is rapidly transforming into a gateway to the wider cosmos. Chandrayaan III's mission serves as a vital step in this grand transformation, unlocking secrets that bring us closer to understanding not only the moon's origin and evolution, but also the broader story of our solar system and our place within it. The cosmos beckons with open arms, inviting us to explore its vast expanse, to unravel its mysteries, and to seek answers to the questions that have long captivated human curiosity. It is in the pursuit of the known, pushing the boundaries of science, technology, and human endeavor, that our collective imagination finds its greatest expression. Chandrayaan III embodies this spirit, reminding us that the quest for knowledge is an infinite journey, one that transcends generations and empowers us to dream beyond what was once thought possible. In this unfolding saga, Chandrayaan III is more than a mission. It is a beacon of hope, a symbol of progress, and a powerful reminder that the future is ours to shape. As we eagerly anticipate the treasures this mission will unveil, we are inspired to look to the stars with renewed wonder and determination, confident that the journey ahead will lead to discoveries that will forever change our understanding of the universe and ourselves.